All right. Welcome, everybody, to the Dallas Personal Robotics Group Builders Night Virtual Edition. My name's Carl Kern, president of this soiree, and tonight we are going to just do the usual and talk around the table about our projects and processes, our progress. However, last Saturday we had a big competition, so we might be a little dry tonight, but let's see. Let's see what happens. And with that, I think Mr. Jean Shi has some kind of an update. So, Jean, take it away.
All right. So, yes, I was busy working on that simulator. But anyway, after Saturday, I finally got around to assemble. I ordered this, like, I forgot, like the first meeting I joined, maybe September. But anyway, it's been sitting on my shelf for a while. So my son helped me to get these frames together, and I'm glad he helped, because I didn't realize there's some ways that I can assemble, like the center groove, these center groove. Actually, I can screw it. So it's basically there's thread in there. So
Yeah.
so now, well, it's good that I have this frame. What I'm intending is normally I'll have it sitting on a little stool, and the wheel rotating, it won't go anywhere.
It is.
And I have these wires all set up, and this board. So I'll be first of all hook up all the wires, so I have something that I don't have to worry about. I'll just then start programming this. One thing I want to ask you guys is, when I was testing the wheel, I can see it's wobbling. But then, I mean, wobbling meaning it's not, the axis is not, well, I don't think it's the axis. It's, I have to understand, because it's wobbling like this way, not slanted, but wobbling like this way. So there's only one set screw here to tighten it. I don't think it's gonna just like running around because of this. It's a small wobble, but I don't know. Is there a good way of correcting it?
So when you put the wheel on, do you put the wheel on with that screw facing on the axle? Basically, there should be a cut, so it's not a perfect circle. That screw needs to be on the flat part of that circle.
I did. It's like a D shape. I'm not on that flat side. Yeah, like this wheel is not wobbling. This wheel, I can see it wobble. So wobble maybe like 3 millimeter, shakes back and forth.
John, do you mean that it doesn't, that when it's going around, it kind of looks like it's doing this? Or do you mean that you can see it flex this way? I mean,
yeah, maybe I can demonstrate.
Can you grab
one
of the wheels
this way?
Hold the wheel.
Shaking this way.
Yeah, hold the wheel. Now,
yeah.
Now just try to move it around a little bit.
It's tight. It's pretty tight.
So it's not. Good practice is never to run a motor straight off. Excuse me, a wheel straight off a motor. Everybody does it, but it's not good practice. The reason is because these things have plain bearings in them, and they're not really made to do that. If you buy the premium motors, the ones that cost hundreds of dollars, they have a ball bearing there, and that's a little bit better. But the way they typically do it is, if they're really serious about it, is they have the motor the wheel is actually driven by a gear, and the motor is driving the gear. Okay, so it's indirect. And if you can wrap it around so that the wheel is supported on both sides, that's even better.
Yeah, I can see how that could be way better. Then you could make that wheel and have bearings on both sides of it, have a gear, either do the either do a belt or a chain or however you want to connect those up, whatever you got. And that's going to be a way more solid connection going out there, and it can be trued up and all the other things that you want to do with it. And that motor sitting there turning, and it's probably accurate enough that you can that motor will turn, and you can calculate that offset, but you have a really hard and fast solid wheel. Yeah, I got that. That sounds like a great idea.
Now,
It just gets real complicated, right? It just gets.
Let me show you. Yeah, it's more complicated. And like I say, for most of the little ones that we make, it's not a big issue. But let me show a few things here, and I'll give you some ideas. First of all, if you go on DPRG Clips, which is the YouTube channel, and if you look in the different playlists, there's a presentation by Greg Mendel, and Greg is the owner of Rev Robotics now. So, but he used to work for Vex, and he makes some good points about how to build the basic motor. But let me show you, give you an example of a Vex robot that's kind of one of their standards.
Or you could use a shim like this. These are little K&S.
Now I think when it's wobbling, it's probably tilted on the axis. I think that's what's going to cause the wobbling.
Yeah.
Yeah.
You see,
If you just have one set screw, sometimes it can, it may not be like perfectly aligned with the motor shaft. It can cock it or twist it a little bit. Spin it with the wheel off. See if the shaft is bent, because that'll definitely make it wobble.
yes, that's true too. And the other thing is, when you put it down on a flat table, do all four wheels touch?
Yeah, they do. Yeah. No,
Sure.
I mean
you
that's
take a
one
piece
of
of
the
paper underneath each one, and they all touch.
Yeah. I think it'll move.
No, I'm not saying it won't necessarily move, but you could have one that's a little cocked.
Yep.
Yeah. I mean, it's not. I'm just a little surprised that, like, oh, it's wobbling a little bit. It's like my car, like a wheel that's not
Could
balanced.
just be manufacturing tolerances again with the, it looks like pretty beefy motors, expensive motors, but this, maybe there's just a defect or just within the tolerances,
Yeah. Okay.
I think you'd see that even on these little inexpensive motors, the little expensive robots that I've been driving around. They wobble a lot.
Yeah,
but it doesn't seem to hurt them very much.
Yeah, I mean, my Pololu Romy, which's got, not the best motors on it. It's got pretty cheap motors on it. The Romy platform, it's wobbling too. It's wobbling. I get a little bit of wobble. I had to, and again, maybe it's just the forces are too much. I found myself having to kind of took it by the wheel and kind of bent it back into shape just a little bit but it's just like you said, without any actual dedicated bearing, these things get bent out of shape at some point.
They'll wear too if you run it.
Hey, John, do you have a set of
when you run it a long time.
Do you have a set of calipers?
Caliper, like a clip ruler?
Or let's see, they're used to measure.
Yeah, I have that. I have a clip.
Yeah. Measure the like the inside diameter of that wheel and the outside diameter of the motor. What I find is, like, you buy 1/2-inch lawnmower wheels, and the hole is smaller than a 1/2 inch.
Yeah, guys, I'm seeing some difference. I think this wheel is, I should push it inward a little bit. So I kind of see this one. I mean, my probably mechanical assembling problem. This wheel is down to the root, this wheel has some is like a few millimeters out. So,
Oh,
but
yeah.
did you say measure the wheel the diameter of the hub?
Yeah, measure the motor shaft and then measure the hole in the wheel. And if they're not like, you know,
I see what you mean.
within 1 or 2 thousandths, you're
Mhm.
probably going to get some wobble in it.
Yeah.
Because the wheel will be eccentric when you push the set screw all the way in.
Okay.
The
Yeah.
other thing, the fact that you had one out a little bit, even a few millimeters, it doesn't seem like much, but when you got to realize that all the force of the robot, that's like a moment. And so being out, you want them as close to the hub as you can get them without, excuse me, as close to the robot body as you can without it rubbing, if you can get it there.
Yeah.
So you might get really like nylon brush and type thing to put between the body of the robot and the wheel, and that way you can push it closer and be more accurate.
I see. So the wheel is rotating, but I see the center one is not. Okay, I understand now. So I will make sure it's not rubbing each other, but close. Yeah, cool. All right, let me try some adjustment, and I'll report back in a little bit.
Great question about your chassis. Those blue aluminum, pieces, are they make block brand or just sort of knockoff?
Yeah, well, it's from Tanner. It's from Tanner. I mean, I guess everybody's seen it, right? They sell these pretty low price.
They're the same as the ones I'm using in mine from Step. The mine are red.
So is it make block compatible or just it looks similar?
It says make block.
Make block, yeah.
I think it's real make block, right?
They bought the excess stock from Radio Shack, but it was basically make block sold through Radio Shack.
Oh, okay. Yeah. I mean, those are expensive. Actually, yesterday, I have still a some left, but look, one takes maybe 2/3 of my stock. So I looked up these things. I remember at Tanner, it was a few bucks, right? Those sell 20, 30 or something, a small package.
On the make block website,
Yeah.
They still sell them.
Yeah, too bad Tanner's is gone. He had piles of that stuff just sitting over there cheap.
Right.
Those make block blue things and gearing stuff and all the stuff we were just talking about. In fact, mechanical wheels there, John, just literally had pallets of it. He was selling at 25 cents on the dollar.
Oh yeah. Yeah, I think a lot of that got transferred to my closet.
Did it?
For those who don't know, for many years, this guy had a store in Dallas, decades, where he would sell things to electronic hobbyists, just rows and rows and walls of discrete components and things like this that he'd buy on liquidation and turn around.
Yep.
And towards the end, I think he was just buying bulk from Alibaba and then adding a few pennies to it.
Yeah, this is the last couple of weeks. I'm like, what I could do is I could go down to oh shit, I can't do that no more.
Can't do it.
I just I'm like, I'll run over there. I can't do that no more. It just.
Yeah, I keep saying, well, I need some resistors. I'll just run over to Tanner's. Oh.
Yeah. And the thing is, if the resistors, you can go in. Fry's still has some. Micro Center has some. They have the kits, but none of them with the variety and the cost. I mean, you're still now. I mean, it's cheaper now to go. Like when I bought 10 of those amp sensors from China, it was cheaper for me to buy 10 of them, and then because of the shipping and everything on the deal. I mean, now I got to buy them in packs of 100 or 1,000 for the stuff that I carry. Now, do I need to? If I buy 1,000 of 220 ohm resistors, That's probably all the resistors I'm going to need for 220 ohm for my entire life. But the thing is, you still got to buy them in the big bulk, and now you got to store them and do stuff with them, right? Yeah.
We're lucky to have that shop nearby.
Yeah.
Yeah. Okay. So yeah, that's my main update. I'm looking forward to start wiring it up and program my motion of these.
With
Like,
Mecanum wheels. That's awesome. You're gonna have some fun.
Yeah, I mean, this is
So-
this is what you posted. So yeah, thanks for the recommendation, Carl. I like it. And you demoed how it moves.
Yeah.
I'm thinking this one would move easily the motion where David the
Oh, yeah,
rotating while linear move. I think this is
Pirouetting,
perfect
yeah.
for that. But I'll try it out.
So
Yeah.
I have a question about the Mecanum wheels and the mechanism. I've seen robots where there's one wheel per side, right? And then we have an example here, and Carl has, two wheels per side. Is there any advantage to having like one of the Mecanum wheels on each side? What's the difference? Does anybody know? You know what I mean by one wheel on every side?
So where they're opposing. So right.
Yeah,
like-
exactly. So literally, they're actually offset 90 degrees, right?
I
Because
saw
you
that.
literally have a wheel sticking out where Jan's hand is, right? There would be a wheel
like
sticking out.
this geometry, but all like rotated, right?
Basically on the radius of the circle, so you could have
Like a cross, I mean, right?
Exactly. Cross. Yep, you got it.
But are they Mecanum wheels or Omni wheels?
Maybe I'm confusing the two.
You know
Well,
the
there
difference?
you can buy robots that have Mecanum wheels on the circumference of the circle, on that plane, and they obviously
Three-sided.
programming, but I've seen you can get them that way. So I don't think they're Omni, I think they are Mecanum.
Well,
I'll see.
the one thing I
You
can
can
see
get them with three
is that
wheels as well.
having that would be the same as having a differential, because the wheels would rotate and move, if you will, and the ones that are regular wheels would give you effectively a differential drive, because the others would just rotate.
Yeah, there you go.
So you're talking
Yeah.
about the three-sided, Chris, or the four-sided?
Four-sided.
Four-sided with. So I could swear that might be the Omni wheel pattern.
Yeah, you could be right. I mean, I
Oh,
Yeah,
may
those
not
are
have
Omni
paid
wheels.
enough attention.
You see the difference in configuration of the wheel? Those are Omni wheels versus the Mecanum. The Omni wheels have axes along their axis. They have it will go 90 degrees to their axis. Mecanum has the expanded rollers.
All right.
See the difference between them?
Yep.
The only ones I remember seeing where there's 3 or 4 on a side like this are using the Omnis.
I see. Okay.
I'm still trying to get my brain wrapped around the mechanics for Mecanum wheels. And John, I don't know if you checked, but did you make sure you have the orientation correct for each of the wheels?
Yeah, I saw a picture online, so I think it's correct. It's like pointing, from this side, it's making more sense.
Yeah,
So-
they all point towards the middle, so that should work.
Point to the center, yeah. Yeah.
You just
I
got to
mean-
get the in the right
Look,
direction.
it never moved before. I mean, so far, I will find out when I plan motion. I'm hoping I can like linearly I can say I want to rotate this speed and linearly move that speed, and I have 2 motions. I sum it up, and it'll move the way like I want it to be.
So how do you measure? I mean, can you actually do odometry, or just is there so much slippage in there that it's just not practical?
That's a great question that I would have answered by now, except we went virtual starting around August.
when we had a whole conversation around how to use optical flow sensors on the robot to look at the ground moving by, because I think the answer, Carl, is that it's probably there is so much slippage that I don't know that apart from looking at the ground, you'd have any idea which way you're going.
Well, you can say that, but I can tell you from the one I showed in the one video that because it has the one I have has encoders on all four wheels, and the last thing I did.
Well, you're operating on a pretty ideal surface, though. If you took that outdoors or anything like that.
Well,
Oh,
it's
yeah.
not meant for outdoors, right? Never. I don't think it.
Well,
Why not? Mecanum wheels do work outdoors. I mean, I'm
Yeah.
not talking four-wheel drive, but I mean just on a little bit less than a very, very smooth floor.
yeah, I mean, it's a matter of geometry, right? If the diameter of the wheels is comparable or much larger than the size of the bumps, then it's fine on whatever surface. But the thing is that you got 4 points. So if one wheel gets lifted up, then it doesn't quite. But it's really funny, Chris, because we had a time in the makerspace when whoever assembled my robot, I don't know who that might be, but I was driving it around and one of the wheels fell off. And so I really don't know how that happened, but the damn thing, it was behaving just as it should with 3 wheels, the same as if it had 4. So it was the craziest thing. So the lesson I have so far is that if you have, like, for example, and I think there's a commercial robot that uses these for kids, $500. But I think what they do is they have they have an axis that goes front to back. So the front 2 wheels are fixed, the back 2 wheels are fixed, but they can kind of like rotate so that you can always have all 4 wheels on the same time on the floor at the same time. So it's kind of like a suspension for Mecanum wheels. You can imagine, like take this axis and this axis and allow them to, and then have an axis here, and then allow like this one to go up and this one to go down towards the floor, these stay flat. So there's a way to do that and keep all 4 on the ground at the same time, which is supposed to be the secret, I think. But what I was saying before is that on the encoder experiment that I got to finish before going virtual and getting distracted, when I just did velocity loops, so run for a certain velocity for a certain time and then come back. So out and back straight, out and back sideways, out and back diagonal, it returned pretty much to go with pretty much the same encoder count. So what I want to do next is actually calibrate that and measure encoder count per distance and see how repeatable it is straight and then sideways.
I'm still a bit dubious about this, Carl, because as you know, in order to go in certain directions, you rotate various combinations of wheels in various ways. And so you'd have to try to figure out the math on 4 wheels rotating potentially in directions that don't indicate the way the robot's moving. So good luck. I don't know. It sounds
I'm sure
tough.
someone has figured the math out, right? We're not...
Yeah, I'm sure. I don't want to meet that person, honestly.
It's just what Mr. Ackley calls SMOP, right? Small matter of programming. So
Exactly.
Hey, Carl, do you have this as a square, like this equal width and height, or does it matter?
Mine is oriented the other direction. It's very much like with this. So it's this is the scale.
I see.
It's longer than it is wide on this one.
Okay.
Yeah, and I'm kind of curious about that, John, as well, because I have a plan that I've been working on. I haven't started building it yet, but I've got the plans for a Mecanum robot that uses the small ones with those little micro metal gear motors. And I've gone over and over on those plans, trying to figure out exactly, one thing I do know is you have to have basically weight balance across all 4 wheels, but the actual geometry of where they are, whether it can be a rectangle or whether it needs to be a square, is interesting. I haven't quite figured out if it matters or not.
Yeah, I would think square is probably better, but yeah, mine was assembled like this because that's all the part I have.
Yeah.
So I'll find out. I'm hoping I can decouple rotation and this trend translation.
Yeah.
And
No, absolutely.
yeah, and
There's
when they sum up together, fine. I hope.
No, they do. You can leverage my repo if you want, because I mean, I have a repo which does the set. I got it from the vendor that sold the thing, but it shows how to mix the. It does a really nice job of. Let me see. How does it go? It mixes forward, sideways, and rotation, and it mixes that into the relevant motor commands.
Ah,
And
nice. Yeah, I would
really
like
simple
to
as it turns out.
do that. Yeah. Okay.
And I still haven't wrapped my brain around the force diagram. I think it basically is that the wheels either pull towards the middle or they pull away from the middle, and then the forces just add up. But I still haven't wrapped my brain around that part of it.
Yeah, I mean, if I have a library to say I want the whole the vehicle body to move like velocity plus rotation,
Yeah.
and it gives me back the 4-wheel motion, I think that's enough for me.
It'll do it, John. That's exactly what this thing models, and that's exactly what the robot that I have does.
All right. I
Oh, yeah.
would
That's
like
exactly
to
how it works.
yeah, look at it. Okay, cool.
And you can drop it. You can see how it's moving sideways and turning at the same time.
But that's simulation, Carl.
No, but I'm telling you, it's accurate.
You mean physically you see the
Yeah,
robot is executing?
That's the same motion that I get in the real world.
Nice. All right. Yeah, that's good. Thanks.
Yeah.
I'll reference that. Thanks.
No problem.
So yeah, that's my update, guys.
Okay.
Thank you.
Well, looks like you made major progress. Good. Looks good.
Yeah. I can't wait to see your physical things start to move around. You guys want to see that? There's one thing that I was going to show Saturday that I didn't do a very good job of showing. So this is kind of like a shout out to Ron's simulator, and it's about our favorite topic, PID loops. So one thing that I found really handy with this. So like I mentioned, I have one loop that attempts to keep the thing centered. I mean, rotated so that it's got the line straight front to back, and I have another one that attempts to keep it sideways correct. So what I can do is I can turn the individual motor dimensions on or off. So I'll turn the forward motion off. If we turn the controllers on, watch it. Okay, Carl, there we go. So you can see if I just drag it, it tries to center itself, right? So what's fun to do then is to go into the, I exposed the PID loop parameters. So, and this is pretty well tuned. Now let's say I detune it. Let's say I put the gain up way high on the turning PID loop. Look at that, gain's too high. And if I turn the gain down way low, it just takes forever and it never quite gets straight. So, and then the same thing with the D term.
You have no integral here, it seems, right?
There's an integral, but it's 0. Yeah, so. Right, there's no integral. Okay, and then the cool thing is that the same trick works for the sideways loop. So there's another loop in here that independently tries to keep it aligned sideways. So what's kind of fun here is you can make it into a bar chart. Well, let's. So what we'll do is we'll slow the speed way down. That's a good speed, I think. And then, so like if you start way off to the side, and this is how you can learn like the dimensions of your sensors range as well too. So now if we put a marker here, and then if we turn the controller on, so that's kind of boring like that, because it just goes there. But if you then turn this forward speed back on a little bit, then what you get So you can actually see that that's nicely tuned, right? It has a nice straight vector, straight to the line, then it keeps going. But if instead you detune that sucker, and I was trying to detune it earlier and it wasn't detuning very well, so let's turn the gain ridiculously up. It still takes it somehow, which I don't understand, but if I turn this gain way up, the derivative.
Is there a
I
max
did
gain?
this before. I was able to get it to ring like crazy. But I don't know what's going on now.
Carl, is there a max gain limit that, regardless of what you put in, it's set to some max number?
You know, that could be it. I may already be maxing it out.
Yeah.
Because one thing that you would notice, like on my contest run, is that the, I can show that, that there's a, I was constantly running into that limit, and Ron's dialog box was telling me that all the time. So, like, if we leave this here, this wants to be, oh, okay, let me just reload it and I'll show you. All right. Okay, Zooks, now it's complaining. This is that too much going on at once problem. Java not responding. Huh.
Yeah, usually on the second try it works if you just hit the stop button and then
Do it again.
you know enough stuff is in the cache, I guess.
Close all the windows, reopen all the windows. It just worked.
All right, there we go. Yeah, so what we're going to do here is just let the guy go. Should be going flat out. Yeah, it's flat out. But you'll see that at some point here, yeah, limited target max turn rate. So whenever it hits some of these elements, it limited to max speed. So some of these transitions, it's hitting the limit, and the simulator stops it. Well, anyhow, yeah. So I don't know what was going on earlier, but the PID loop I thought was kind of cool, and that's the only thing I had to show. So I'm done.
Yeah, that course is going to be the most simulated but yet unsolved, challenge. Simulated millions of times.
One of us is going to do it sooner or later.
Yep.
Well, especially now that you guys have had all this practice, I would hope that all the stuff you guys have learned from doing that in the simulator would have somehow transferred across, because what's the whole point of a simulator is to learn, right? What you're going to do when you get to Mars.
Well, I can tell you my practice in the physical world helped the simulator, so it better work backwards.
Yeah, the challenge backwards is, I would have to use a camera. I mean, otherwise you'd need like a crazy number of line sensors, but that's fine, right? But I don't think it's physically possible to position the camera the way I had the line sensors positioned, right? Because, unless I have a see-through body, I suppose, okay, that could work, or a hole in the middle of the big hole and just a frame on the outside, I suppose that could be done. But that would be the challenge in my mind, replicating the geometry and positioning of my sensors in the real world.
Well, Chris, you're aware that Pololu does sell that line of those sensors that go up to like maybe 32 or whatever. They have a whole,
Yep.
There's dozens and dozens of them. And I know that they don't have a curve, which I think you use 2 curves in yours. They don't have a curve, but it would be possible to maybe buy like groups of 2 or groups of 3 and sort of simulate the curve roughly.
Mm-hmm. Yeah, I would need a bunch of those. I mean, again, I'm not using all the lines that I had shown, but even if I trim it down with the bare essentials, yeah, it still adds up to a ton of sensors that I'd have to buy from Pololu. So, I'd want to go with the camera. And Yeah. Anyways, if I said I'm gonna try to sort of figure out how to get TensorFlow to do this, to do some of this logic. So that's probably my next my next project. But I'm still getting up to speed on TensorFlow. I've just gotten as far as just running a couple of the examples. Now I need to figure out how to actually get my own data fed into some neural network. Well, I have to collect data, which is probably going to be the more labor intensive part of it, actually writing some code in the simulator to collect some data that I can then feed into the neural net.
I did actually some work earlier in the year that you might benefit from. Is I just took the regular Pi camera and I set its resolution very, very low. And then I was literally just reading the pixels off the camera. And I did it, I don't know if you remember, but I was doing it I had a pink LED and I was pointing it at the pink LED.
Yeah.
And that was almost trivial. You just set your resolution on the Pi camera extremely low, and you'd probably want to use some white LEDs for lights to get a nice bright light in front of the robot, and then just pull a selection of those pixels out that matches the pattern that you're using, and it wouldn't cost anything. It's just the cost of the
But I'd
camera.
have to build the real course, right? To use a real camera to collect the data, I'd have to build the real course, which is that's the tough course to build. So it would seem to make sense to use the simulator to collect the data, but again, it's just a small matter of programming, I guess, right? To
Well, you say
rig
to build
something up.
You mean print the course? You just take the PDF and print it, you mean?
Yeah, print it, but exactly. I mean, it's not that straightforward because each tile is a 12 by 12 instead of an 8.5 by 11. That would have been a better design, I think, to make each unit an 8.5 by 11. But so I don't know if I would be able to print this thing and then find room for it and all that.
It was based on 1 foot square floor tiles, so
Which makes sense too, but in hindsight, right?
yeah,
it's hard to print a 12-inch by 12-inch image.
yeah.
Well, that's where we cheap, and we just send it off to stickers and banners, and $140, and a day and a half later it shows up.
Nice. So anyway, so that's what I'll be trying to see, get my feet wet in neural net. Other than that, just wanted to show this since we were talking about the motion of the mecanum wheels, which reminded me, it's almost like similar to a drone and how it moves, right? So I actually just bought this recently. That was the only Thanksgiving holiday, deal that I ended up not resisting. I didn't buy any other Polar Loose stuff. I had everything, so I decided to actually try a drone. Never had one. Never had any other flying gadget. So that's my first flying gadget. And so again, I'm gonna play with this a little bit. Haven't played with it much. It doesn't have a lot of bells and whistles. This is the DJI Mini, so it doesn't have any AI in it. It's not autonomous. It doesn't do, follow me. It does a couple canned maneuvers. So it's not, again, it's not super high on bells and whistles, but nonetheless so. And I decided to, play a little bit with these kind of toys and see where that takes me. I don't think it's possible to, program this sort of thing. I mean, I don't think there's an SDK for it or anything like that. But so if at some point, if I get the hang of this and enjoy flying objects, maybe I'll graduate to a drone that you can actually program, right? Because I mean, there is a lot of stuff out there I've seen where people put their own electronics on a drone body, instead of a wheel body.
2.5 years, Chris. But 2.5 years ago, the DJI Mavic came out, Mavic Air, I think it was, and they announced an SDK specifically to talk to DJI, and that was the lowest one at the time that could support any of the SDK and any of the programming and any of that kind of stuff going on. They may have made some advancements, so I would get on the DJI's website and go look, become a developer on that, and the SDK was in C#, and basically it was able to pull images from the camera and then go run up and go do some cognitive services, because the demo I did in front of a whole bunch of people was we threw a bunch of fruit on the ground plus a guy in a banana costume, and it was able to tell banana from the apple from the guy in the banana costume. And I hand flew it because we were indoors, and flying one of those things indoors is kind of a terrifying thing, because if you ever seen those blades get into anything that's flesh, it's a problem. That's all there is to it. And so we hand flew the thing, but it was able to detect them in real time. I say real time, near enough real time for government work, anyways, and that kind of thing. So they might have something out there now, because it's been quite some time since they announced all this stuff.
That's good to know. Again, this is one of the smaller ones. This is the below 250 grams, no license or registration required kind of deal, right? So this is not one of the bigger ones.
It may or may not be there, but it's interesting. It, you know, go look and go see, because I knew they were going that direction, right?
Good to know. Yeah, thank you.
Well, and also we were talking about Mecanum wheels and all that, and of course the conversation we had like 6 months ago, I think Ray, you were doing something with it as well, is that these little optical flow sensors, of course, that are now sold by Pimoroni and other companies, they of course were designed for drones. So this is actually the sensor that was meant to go on a drone. And I think, Chris, wasn't it you or somebody, we actually got in contact? No, it was who was it? We got in contact with Pimoroni because there's another version that's designed to be able to. Oh, yeah, yes. We got in touch with them, and they're in theory going to make. There's another version of this that's meant to work like really close to the ground, and is designed to work on ground-like surfaces and notice like gravel and things like that. And in theory, they're coming up with a new version of this that's going to work as a robot style on the ground rather than 30 feet in the air. So we're still waiting for that. I suppose I could go since I started blabbering already.
Well, before you do that, I want to say I post something out there. So if y'all go to that spot, it actually looks like a pretty good description about those reels. Or I'll share the screen, show you the first page, whichever route you want to go. So I can figure out. Share the screen. Oh, grief.
Oh, yeah.
But yeah, that looks like a pretty good description about it. I mean, it's very well documented. It looks like about the armor.
Presenting, John?
What? No, but let me try.
No.
Do that since I have the window up already. Once I figure out something, present now. Pick a window. And
that's from our friends at FTC. So
yeah, I'm trying to figure out.
Kids keep ahead of us.
You have to click in the window.
I know. I'm trying to figure out which window to click on right now, though. It's like
when you open it up, there's a little square box.
This is it. Yeah.
So it says share. Then you hit the share.
Yeah, but I have a couple windows running, so that's why I'm trying to figure out which one to click on. So yeah, it looks pretty good. I mean, he talks about the physics and the direction, the fact that it's off. Instead of being parallel, you have the FC, the FS, FT equals, whatever that is, T/R. So, yeah. And he talks about, the base of the three different angles off your chassis with the center of the chassis. So, yeah, it looks like they really should be same distance all spaced out because your center can be effectively changed by the length of the body. And then
I'm going to warn you guys off of Mecanum wheels. I've got I think I have 3 robots downstairs that are Mecanum wheels. They work great in the conditions for which they work great. Otherwise, they are trash.
Because of the slippage problem?
You have a very level surface. It needs to be pretty consistent in its friction. Right. And for it to work, and it generally benefits from like being on foam or carpet or a very short grass. That kind of thing, but it needs to be very, very even for you to get consistent results with Mecanum wheels. In those ideal conditions, they are absolutely phenomenal. So I can tell you, so that is Game Manual 0. It is put together by a bunch of FTC teams in cooperation, and it is a whole bunch of how-to guides. In FTC, you're playing on a foam field that's 12 feet by 12 feet. It is perfect conditions for those. Until you get to some years, this particular year's, the new challenge is perfect for it. There aren't even any bumps or any obstacles to surmount in the field. It is just a wide open surface. And they are beautiful for that, and they will perform incredibly well. And I'm going to say this year, probably 90% of teams will be using Mecanum wheels because they're a perfect fit for this challenge. They are horrible in real world situations. You have to have your load balanced over each of the wheels about the same as well. So if you have a robot that has big arms on it or anything like that, and you can get offset loads or something like that, your robot is going to start behaving differently as a result. Yes, if you do have an omnidirectional, so most of the teams who do use Mecanums will have a correction mechanism where they'll have Omni wheels also as part of either Omni wheels or a visual odometry tracker like was just talked about, but and that Pimoroni might be coming out with as a correction mechanism, right? Because if they're not under, if the Omni wheels are driving encoders that are not under load, then they're going to spin freely and they'll be able to help correct your robot starting to drift. But if you're expecting to be like highly precise navigation and you have any of the situations where Mecanum wheels aren't so great, then you're going to have to correct for it. That's my little diatribe. I'm just saying, be careful what you ask of these, because there are conditions, real world conditions. It's not going to be a great thing. So if you want a general purpose robot, I would recommend going with something else.
Thanks for that, because actually that little robot I've got, I don't have. I mean, in my house, I've got wood floors in some places, but I've got a lot of different changes of carpet and different carpet densities and things like that. Arabic rugs and stuff. And then I've also got a wood deck out front that has, the little bumps between the pieces of wood and stuff. And I have a funny feeling that since these are not very big Mecanum wheels, they're the small ones, these guys, I have a funny feeling that they're going to perform as you said. But I kind of know that almost. It's like this is sort of the experiment to see how bad they are.
They would be great for DPRG's tabletop competition, right? So in artificial scenarios or controlled scenarios, a warehouse, for example, is an ideal location where you have a consistent floor surface, and but if you're navigating multiple different kinds of terrain, it's not going to be a good choice.
Good to know. Put a big downer on my project now.
I'm sorry, man. I'm very appreciative of the lessons that we've learned as a result of using them. And again, in our competitions, they're almost a no-brainer.
No.
Kareem, have any of your teams done an articulation so that they put the front two on an axis, the back two on an axis, and let them rotate so that they can always keep all four in contact with the ground at the same time?
Say that one more time. Are you talking about a suspension?
Yes.
Sounds like it.
Yeah, these tend to not be used with suspensions, partly because, again, we're all operating on a foam field in a artificial environment. So the field itself is providing some suspension for you. It's very rare to use. In fact, I've seen one team that has combined Mecanum robots with a suspension, and so I don't have direct experience on how that performs.
Okay.
But again, it's the weight distribution. It's not so much the momentary interruptions that are the big problem. It's the weight distribution. So if you have an offset portion of your robot or a varying load or something that is carrying around, then you're going to regardless of the suspension, you're still going to have problems because the friction is going to behave differently and your navigation isn't going to be as predicted.
And that was kind of an interesting thing that we talked about before with these little optical flow sensors, because I've got this conflict is that I want to have the optical flow sensor at the very center of the robot, in theory, but that's actually where I need to have my battery as well. And the little thing that I had done was I'd aimed that down through a little hole that I'd cut about 80 millimeters off the ground. That whole little container area needs to be in the very center of the robot so it can see rotation. Although actually you can't get rotation on these things. I need to have another one to catch rotation, but I need to have one of these at the very center of the robot, but that's also where I need to have the battery.
You don't need it at the center of the robot, just like you don't need to put an IMU at the center of a robot. So an IMU can go pretty much anywhere. And if you're going to have two of those, you're probably going to want to. You might want them close to the axis for your primary wheels, the central axis of the robot, but on either side, so that you maximize the differences in the readings. And if you're trying to derive rotation from that,
yeah,
otherwise I would derive rotation from the IMU. And a single one of those, it doesn't really matter where it is facing down. If you're correcting, it's just covering your translation, whereas your IMU is covering rotation.
Yeah, I was sorry to interrupt you, but I now remember that conversation because I do have two of these, and I had bought two of these with the idea I was going to use two, and then we went this whole process I went through, and I've decided to only use one. And you're right, it doesn't have to be at the center, but I do have to get rotation off the IMU. Yeah. All a lot more complicated than a normal robot, though.
But those are still valuable things to have in any robot, right? So the only difference is you're not going to have the side-to-side movement if it's not an Omni or a holonomic or Mecanum type system. You're not going to have side-to-side, but it's still valuable to have that translation forwards and backwards, and it's still valuable to have the rotation from an IMU. So even though my teams, I try and encourage my higher end team to actually not use Mecanums, because that's more unusual now in our competition. They still need to have that kind of feedback.
Good to know. I guess I can kind of give a little update since it's kind of in the same vein as what we've been talking about. I was going to do a little demo last week, and I can't do it this week because I got sidetracked on kind of a bug that I discovered. So I don't know if you can see, but let's see now. But the whole front of my robot now, this bumper sensor is now disconnected and held off from the robot because I've been debugging a problem I was having with it, which turns out to be entirely in software. I thought it was a hardware problem. Actually, what I found was, and this is a question that maybe we can deal with in the mailing list, is I effectively was trying to get like a Schmidt trigger or a debounce. What I want on the bumpers, and this is maybe a general purpose question, is that if I'm polling the front bumper switches, and I happen to get a mechanical switch actuation that doesn't happen at the moment I poll it, it'll come back as a 0. And that was my bug, effectively. And so what I was trying to do is create kind of like a debouncer that could have a variable length. And this is a Python question, maybe. But what I want to do is have it such that if I ask the front bumper, has there been a bump on the switch, I'd like to be able to set a time delay that it basically says, okay, snap, there's been a bump, and it holds for maybe a second or something like that, or a certain amount of time. And then if I poll during that time, it'll always come back as true. And that was basically my bug. Has anybody kind of come across something like that? All right, well, yeah, that's basically the problem I was having, is that I would trigger the bumper.
Why do you want to have it during a certain amount of time?
Well, what I'm getting at is that sometimes I would be clicking I've got little lever switches, and sometimes I'd hit the lever switch and nothing would happen, and it would just be that I'd clicked it right at the moment it wasn't being pulled.
Right. But the key question is, why does it need to be during a certain amount of time? Just have a switch that's basically on or off. So you have a variable that says, hey, it's been hit, and then you reverse it, flip-flop it.
Oh, I see. Basically a toggle.
Yes.
Oh yeah, that's another way to do it. A toggle that you have to reset. Okay. Okay, that would work. Thank you. That would work. Ray?
Oh no, I was mimicking Ron there.
Is waving.
Oh,
Murray,
waving his hands
so I got a question for you. So it sounds like you got maybe two options, because you got the sample rate question.
Yeah.
If you don't roll fast enough, you're not going to catch it. But then the other question is, how do you have the pins fed into your software? I mean, are you putting them as, because I think you can configure certain pins as like edge detection mode.
Right.
So
I'm not using the Raspberry Pi, actually. I don't know if you remember, but what I've done is my whole front bumper now has one of these little guys, which is a Nuvoton 51, which is an 8-bit processor. And this is its own little microcontroller. And you've got 6 PMW or digital pins and 8 analog pins. And so this gives me, is up to 8 analog to digital converters and as many as 6 pins that I can use, and that's enough. So what I've done is I've mounted this on my front bumper, and then I only have to have an I2C connection between it and the Pi. And so it's really all inside this thing now. And what I want to do I think actually I like John's idea of just having a trigger that I reset. That's probably the easiest.
In the software, right? Yeah.
Because unfortunately there is no trigger high to low or low to high. It's just basically a read on a pin.
You gotta read it. So yeah, so you gotta do the software edge trigger.
Yeah. And then on the IMU question, I've been basically thinking about using both a B&O 55 and an 85, and I've been playing around with that. And I haven't had much luck with the 85, mostly my software limitations. But I have been using an ICM 20948, which is, again, one of these little tiny breakout garden ones. And it's just a standard IMU, I think. But this one's actually quite reliable. It's surprising. I can have this down on the robot, surrounded by all the other electronics. And this gives me a pretty good heading. And so what I might do is use the B&O 55 in combination with this, which is using a magnetometer, by the way. And I'll have 2 headings that do seem to be pretty reliable. I'm kind of surprised. This is not an expensive IMU at all. It's not fancy even. And for some reason, it doesn't seem to get affected much by the robot being within a few centimeters of it. Whereas I've got the 055 way up on a stem, like 25 centimeters away from the robot. And this one, for some reason, doesn't seem to have a problem. So I'll probably use a fusion of the 2 of those to get my heading. And apart from that, I think that's about. Oh, I did have another bit of news. I've been using a new Pi B 3B plus, I guess it is, and been playing around with it. And I had gone ahead and bought an Orange Pi 4 and was playing with this, and found out that when I tried to plug in a standard Raspberry Pi breakout garden connector, that smoke came out. Ooh.
Oh boy.
Yeah, and I have contacted Orange Pi and tried to get onto their forum, and they haven't even responded to let me onto their forum to ask the question, because what I want to find out is, does their 40-pin GPIO, since it's called a Pi, an Orange Pi, is it compatible with the Raspberry Pi's GPIO? Because I cannot find their pinout anywhere. And so it may be that they simply don't have the same pin arrangement as a Raspberry Pi, but I can't find any information online about that. Because it'd be surprising for someone to put out something called an Orange Pi and have a GPIO that is the same size as the Raspberry Pi and doesn't have compatibility. That would be really horrible. But that seems to be the case, because I now have a dead one of these things that got fried on the Orange Pi. So, but anyone have any experience with an Orange Pi?
No.
Nah. So this is in the long line of all these things that I've bought over the last 6 months that I'm not using because they're not compatible, or for various reasons. Yeah.
You can't tell until you buy it.
Yeah, and I think I mentioned on this Fire 3, this NanoPi Fire 3, that the actual pinout was not meant to be the same, but it turns out it is Raspberry Pi compatible, but their I2C bus turns out to be using bus number 0 rather than bus number 1. So I have to use the pins over here rather than the pins on the end. but in theory it should be compatible, except it's not pin compatible in that sense. So lots of playing around with stuff that doesn't really work very well. So yeah, apart from that, I think that's about it from me. Trying to get my operating system together still. It'd be nice to actually have a functional robot again, but yeah. As David keeps reminding me, that's sort of the basic. If you don't have a functional robot that can actually, you can put it on the ground. What was it? Someone saying that they had a test where you had to just turn the thing on and it would actually just come on and move or something like that. That was considered a success. So, yeah. Anyway, that's it from here.
I think that's level 1.
Yeah, I'm not at level 1 yet.
That's all right.
Or at least I'm not there at this point. I was before, but
you get back to it.
Yeah, and I'm almost at the point. I mean, I'm testing a lot of different things, and like this whole idea of using 2 IMUs to get a heading. That if they match within a certain number of degrees, I'll consider that a reliable heading, and then I'll use that. Otherwise, the robot won't have a behavior based on heading. So I'm getting fairly close to that, and I'll probably end up using a BNO55. Maybe I'll try the 85 a little bit more and see if I can get something out of it. But this little, where is it? Wherever I put it, the AC, I forget the number on it. It's kind of an oddball one. Here it is. The ICM 20948, this little guy. They're cheap, and it seems to have a pretty good heading output. So I'll keep working with that one. It sure is complicated doing IMU stuff, though, isn't it? Man. It seems to like PID controls are one thing, but IMUs, man, I'm stumped.
Okay, that's our next TLA is IMU. Okay, cool.
Speaking of pin, I have something to show you that.
Bring it on.
So let's, click there. So there's a spot that has discussion about pins. So if you're really wanting to know your math,
oh yeah,
you might look at that. Okay. So that's in sort of the same pile of stuff, but yeah, they have a little bit about pins here and that. So y'all might want to look at that spot too. And the loop.
Well, John, I'm happy to say that I've gone through that trial by fire, and I actually have a relatively functional PID controller now. So.
Okay. So you don't need this.
And I can even specify velocity in centimeters per second. So that works pretty well. So.
Calibrated.
That's one thing I thought was kind of interesting, is that one of the things about the BNO55 that they advertised was that the data coming off of it is actually in SI units. And I thought that's actually not a bad policy in terms of robots. Rather than saying I want my robot to go 50% or 60%, it's not a bad policy to actually figure out, based on your wheel diameter and all that, to be able to say I want to go a certain speed in centimeters or inches per second. And I kind of like that when you're programming, because then there's a certain rationale. You can go, oh, that doesn't sound even reasonable. 1,000 meters per second is an impossible number for a robot. Whereas 70% doesn't really have that feeling of doing science anymore. It's just turning a motor on. And so I've kind of taken that on board. And what I'm trying to do is have all my sensors and all my data converted into the, not an SI unit necessarily, but something like that, centimeters per second. And it's kind of helpful when you're doing your programming too, to actually get it into a number that makes some kind of sense rather than just, let's say, a decimal.
Nice.
In any case.
Yep. Cool. All right. Well, thanks. Let's see. So, Mr. John, what have you been doing since the last we met?
In my case, nothing much other than surfing the web a little. So,
fair enough. All right. So, Kareem, how about you? Have you had any luck to do robot-y things since Thanksgiving, or even stuck with the other distractions?
Mostly the other distractions, but the reason I didn't attend the your competition last weekend was because one of my teams had a virtual scrimmage that day. So it was our first scrimmage of this new season, and we were trying to figure out how a virtual scrimmage works. So our goal was not to score points. It was just to complete the process of going through a match. And so we got a few points here and there, but we were 10th place, something like that, because we've only had 3 build meets so far. But it looks like the competitions are all going to be virtual, probably through February at least. My guess is going to go longer than that. But we've always hosted an FTC competition, well, for the last 3 years, and this year we didn't do it in December. So we're thinking about hosting one of these virtual competitions. And now we've been through the scrimmage, we sort of got the lay of the land, but the trick for the real competitions is that, unlike a scrimmage, it's still going to need judges. And so I have no idea if we're going to be able to recruit judges this year. It's going to be
Kareem, how do they do
some ways
that?
it's easier, some ways more difficult. Sorry, Doug, you were saying?
Yeah, how do they do a virtual scrimmage?
So it's an honor system. There is a live scoring app that they've created. So you go to the website. It provides the match timing for you. It provides the setup, because there's always an autonomous random flip at the beginning that changes what your autonomous program has to do. So that's all built into the app. So it is real time. There's real time scoring as well built in. So you need to have somebody who is running the robot. Usually it's 2. There's also a human player involved who's feeding the elements back into the field. And then there's got to be somebody doing scoring, and then another person doing video to capture it all on video. The actual rules don't say that you have to submit video. Everybody is submitting video after the fact. But instead of it being sort of a live competition, although the competition is technically live and you can score the results of your time to match in real time, and it's posted on the website to other teams. The actual video submission happens after the fact. But the competition is actually a week long instead of a single day. So you have a week to submit your matches, but there will be a single day where teams will do their video presentation. So they'll be using Zoom or some sort of online meeting client to present their robot ideas and concepts to a judging panel. Just like normal, it just won't be face to face.
I understand that, I can see, but so they actually do a run and video it, and
right.
But how do they compete? Like, as teams, or how did you said you came in 10th place? What does it just mean that your run had less scoring elements than the other 10?
Yeah, we actually submitted 6 matches. So in a typical tournament, you have 6 different matches. Yeah. Normally, you have 4 robots on the field at the same time, but these are all happening in different locations. So the field setup is a little bit different, and you're just taping your own robot's performance. So there's no interactions happening with other robots, and each team is in a different location. So it is a truly virtual thing, and there's no like everybody getting together. There's just planned judging. There's a judging schedule for the presentations, but nothing else is interactive so much, except that the website sort of pulls in the results from everybody who's participating and creates a leaderboard.
Huh. And of course, each of the teams themselves are together physically, but they're playing on on a different field. So
yeah, they're all playing on different fields. Exactly. Yeah. So there's not the matches between teams are not synchronized. And the rules have changed this year because there's always been this alliance element. So how well your partner does affects it, but in these remote events, there's no such thing as an alliance. The idea is that by the time they delayed the whole season, so that normally it would be April, or April or May when the World's Championship happens, but they're going to delay that till August this year, hoping that will so that it will convert from a mid-season, early season will be virtual, and they hope to convert to classic competition play by the end of the season. But we'll see how that goes.
Nice. That's cool. All right,
Anyhow, I may be testing the waters with you guys on the list to see if anybody's interested in doing remote judging in the mid-January timeframe. But let's wait on that. I'm not sure if I'm going to offer to submit my team to that.
Just let us know as we get closer.
All right, we'll do.
Thanks. So, Mr. Chris, have you had? You showed your new DJI thing. Have you had any chance to do fun since Saturday? Have you just been resting and basking in the laurels of?
Mostly resting. I think I gotta do stuff that takes me away from the screen a little bit, so a little bit more hands-on activities.
Yeah.
So that's where the drone comes in. I did have a question for the group. Has anybody bought anything off of AliExpress? Any good or bad experience? Do you use your real credit card? Do you use one of these one-time use credit cards? I mean, how do you go about buying from AliExpress? I mean, it's one place I haven't bought stuff from, but
I did.
Actually buying stuff without any issue. I've received everything I've purchased. Sometimes it takes a long time. Sometimes it comes like next week to New Zealand. And like I bought the Fire 3 Nano Pi and and the Orange Pi as well. The Orange Pi came off AliExpress. I think it comes down to that if you look at Rakuten, which is the Japanese one, and AliExpress, they're not actually businesses that do anything except bring other businesses together. So
right,
like
I understand.
What about the credit card aspect? Because
Yeah,
that's a key point.
I just did AliExpress about a week and a half ago, maybe 2 weeks now, and all of my stuff finally has shipped, which is always good, which means it'll eventually will show up. And I didn't use a credit card at all. They sent me to a PayPal, and I used PayPal to pay them, and so they don't have any of my information whatsoever, only that they got a little money from me through PayPal.
Okay.
Yeah. And like I said with the Orange Pi stuff is that the company that makes the Orange Pi and the Nano Pi, they're quite large companies in China. They're reputable companies. And so I think if you were to look at the size of the company that's actually on AliExpress and judge based on that, you'd probably be okay. But there's a lot of small vendors, and I would definitely shy away from them.
Yeah, I would like to share some of my experience. So this set of wheels and motors are from vendor AliExpress. My son is playing. So I want to tell you, 6 wheels. I mean 6 motors. There's 2 that didn't work, but the customer service is okay. So the first 4 came in, 1 didn't work. Can you guys hear me at all?
Yeah.
No.
With some nice ambiance as well.
And I actually chatted with the customer service. It was like, I mail you a motor. It's hard. How about you buy another one? I thought he was like, okay, how about I buy one more, right? So when it came in, I was like, okay, I'll just buy it, but make sure you test it. When it came in, it's 2 motors. So I guess he was meaning that you buy something, I'll ship the replacement together with this new one. So anyway, it turns out maybe one of the 2 was broken as well. I didn't troubleshoot that. There's another incident a few years ago. I bought like a small card, this kind of small memory card, and it's like fake card. So then I realized it. I was like, well, I mean, it's more like the 4 gigabyte saying 64, but it's just
Yeah. So how do I know if it's a big vendor or one of the smaller vendors? I mean, do they have like a system by which I can tell if it's a reputable vendor?
Not sure, but you know, with that incident, I just told the credit card company, I say this is not right, and they refunded me. I mean, I guess using a credit card is not a bad idea. You at least have some protection that
You do on PayPal too.
you refund you in case there's issue.
Mhm.
Yeah.
So yeah, I would use a credit card. I mean, I don't know what can happen if I use a credit card if the vendor is like not an honest vendor. Can they charge
Take the credit card out.
Oh, right?
PayPal is a good approach.
Yeah. Chris, my experiences with AliExpress is probably very similar to Murray's. You know, I think I've got everything that I've ever ordered from them. I have had a few pieces that were broken, and you know, sometimes you can get a refund, sometimes you can't. You know, when I'm buying from China, I probably go to Banggood first. Okay. Now AliExpress is going to have the lowest prices. You can't beat them. All right. But sometimes it depends on just how unique whatever it is you're looking for. If it's, you know, I'll be quite honest, a lot of times I'll look at AliExpress and Banggood, and then I look at Amazon, and you know, I figure Amazon is going to be 2x, and if it's less, you know, if it's around that, but I get it tomorrow, you know, sometimes it's worth it. And with Amazon, you've got 100% recourse, and so you have to kind of pick out how much you really want it. You know, if it's something that you're saying, this is cool, you know, I'd like to look at this someday, and but I don't care if it comes in 2 months because I've got enough crap to do before then. Then it's a good vendor. But you know, you have to look at your time is the most important thing that you've got. You know, so.
And I can go along with Doug. I mean, I agree that I wouldn't use a credit card. PayPal is probably the safest. I actually have used a credit card when I was dealing with the Orange Pie vendor, because they do, like a lot of these things, tell you how many followers, and like some of them have like 35 followers. But I'm not pronouncing this correctly. It's the Shenzhen Sulong Software Company Limited. They have 16,011 followers, and that's actually the company that manufactures the Orange Pie. Now, if you search for Orange Pie, you're going to get dozens and dozens and dozens of little named companies that have like 34 followers, and I would just avoid those. But if you get a company in China that, you know, you can either search on the company name itself or just look at the number of followers, and some of these have got like, you know, 6,000 followers. It's like Amazon. You get a lot of crap places on Amazon as well, whereas, and as well as Rakuten. And AliExpress, to me, you know, they're giving that percentage of positive feedback number and then how many followers. And if they've got thousands and thousands of followers, you're usually dealing with a legitimate vendor.
Yeah, I think the AliExpress, you know, the company AliExpress, actually, I think is trying to do the right thing. So, I mean, you know, it's like I say, it just depends on whether you're willing to wait a month or, you know, if how much you want it, how unique it is. Those are the factors. I wouldn't be afraid of AliExpress, but it wouldn't be the first place I would go to. But a lot of people use it exclusively. I mean, they go straight to AliExpress and pick it up. You know, the guy that has the Swiss accent, you know who I'm talking about on YouTube? You know, he uses AliExpress a lot. So, you know.
Okay, good. That helps.
I've placed
I mostly use AliExpress too. And like Doug says, if you're not in a big hurry, it'll come.
I just checked. I placed 8 orders in the last 2 years from 5 different vendors, and I've used a credit card. I felt comfortable with credit card because I figure that they have the payment processors and they have fraud protection built in, on probably better than PayPal or the others. And like everyone else has said, I mean, the vendors I've found have lots of reviews or good interaction. And I think they pay attention to their social feedback, and they don't want to get the bad star ratings. So even though the language barrier might have caused some slow issues in the past, I believe that they've all tried to do well.
And they even harass you in email. I mean, AliExpress even harasses you in email about every order, saying, "Has your order come in? Has your order come in?" They want to know whether you've been had success or not. So I agree with Doug. They are trying really hard to do the right thing.
I've seen that same experience. And could you rate this person and all these kind of things? It was just delivered. Is everything okay? Would you go read? You know, that kind of stuff. I've seen them do that kind of stuff. Yeah.
Yeah.
Okay, cool.
And I guess the only reason I was willing to make as big an order as that Orange Pie was that when I went to the orangepie.org site, they actually said the name of the company that is Orange Pie. And at the bottom of the Orange Pie, it says Orange Pie is a trademark of the Shenzhen Zulong Software Company Limited. And that is actually the one that shows up on AliExpress. So I felt a little better about that. I wouldn't necessarily put a couple $100 order in there to an unknown vendor, though. No way.
I've had on occasion their buy it now links from off of people's sites send me to the AliExpress site. You know, just send it right there. I mean, that's what their store is to go buy their stuff.
Right.
Hey Murray, I put a link in chat. I don't know if you saw it. You might want to click on it, see if that's your model. It's a pinout, a GPO, general purpose IO pinout. I don't know if it's your model or anything, but it might
No,
be.
it's not, unfortunately.
Okay.
No, I've got the Orange Pie 4, and I searched all over the place and haven't been able to find a pinout for it.
Have you looked at the images, pinout images?
Well,
you would like to think they wouldn't change their GPIO header pins from one version of the next, but it's not beyond them, right?
Well, there's a lot of models. The Orange Pie has about 30 models. There's quite a lot of them. Well, that does look like a Pi compatible one, doesn't it? Yeah, I'm just looking at it right now. It looks pretty compatible, but that's the H3, and you'd hope the Pi 4 would, and it may have been something about this board particularly, but I'm not going to plug anything into it until I've got some confirmation that it actually is compatible, because these little buggers aren't cheap. Well, they're not expensive, but it's most of the time it takes. I get something from England now, and it's going to be weeks before it gets here. So.
All right, so let's see. So Mr. Doug P., I think you've probably been pretty busy. Have you had a chance to do any fun stuff in the last week? You have any big plans for the next week?
Me?
Yes.
I've been doing web work pretty much and trying to get stuff straightened out, but we're
thank you for that, everybody. I mean, that's a lot of work you've done. That's really appreciated.
I think I got it all taken care of now. So we're I've got one more task that I've got to do, but all the competition is up. I got it on the Hall of Fame and everything, so as well as in the post. Now, I was wondering, and I'd like to kick around sometime with, maybe offline with Ron. Ron raised an idea in his one of his emails where he was talking about he was kind of interested in doing a simulator of a robot Columbus or a robot Magellan. Am I right, Ron?
Yeah, well, kind of that idea.
Yeah, but I'm just saying is I was sitting here, since I've read your email, I'm sitting here thinking of how you would do that. How you could like have the terrain would have a variation in it, or difference, and so that like when you were going across, you might hit a sand area, you know, or something, or a few other things. It just really sounded like a good idea, and it could be kept 2-dimensional. You know, you wouldn't have to do a 3D thing,
Right.
and I'm not trying to get you any more work. I'm just saying is I was intrigued by that. That was an interesting idea.
Yeah, I've kind of got a few ideas. I guess I'll see if I play around a bit. I did want to do, or my thinking is to keep things as simple as possible. I'd like to build things off of LFS so that anybody who's played with that wouldn't have to learn much to do something else.
Yeah.
So let me fiddle around. I mean, I've done simulators. I was just looking at a maze simulator I wrote. It was 2006. So anyway,
Can you do
just
tar pits,
let's just, what's that?
I said, can you do tar pits? You know,
Tar pits. There you go. Little
See,
energy, negative energy.
I would think that once you get into that sort of range of complexity, you'd want to go with something off the shelf.
Yeah. My thing is everything off the shelf is frustratingly slow. Nothing I've seen will run faster than real time. But I think I've got some good ideas, especially in the area of things like obstacle avoidance, you know, like David Anderson's example, driving around a room or whatever with obstacles and things like that. I think I can come up with a simulator that would run faster than real time. I love that for development. I don't know if
That's for sure, right? I mean, that's one thing that you know, I don't think any of the off-the-shelf simulators, you know, can run much faster than couple X real time on a fast computer in a simple sort of model. But you know, so that's a trade-off.
I think I can do what we do with, we'll say like can collection and maybe even let's go beyond a rectangular room. I think I could do that a lot faster than real time. But I guess rather than to say, oh yeah, I could do that, I guess I should just do it. And if I do it, then.
Well, yeah, I was just saying is, I just thought it was such an intriguing idea.
Yeah.
I mean, I don't, like I say, I'm not trying to get you anymore.
No. Well, just depends on how many contracts fall my way. If there's not much contract work, then I tend to do stuff like this. So.
Yeah, that was kind of cool.
So unless I run out of money, then I have to, you know, I don't know what I do. So anyway.
Is this like, are you guys familiar with Travis McGee? The guy that lives down on a houseboat in Florida? It's like John A. McDonald wrote detective novels. And Travis McGee basically lives on a houseboat in Florida, and the only time he'll get any work is when he runs out of money.
Yeah, that's kind of how I am.
Yeah. And then he'll go recover money from some criminal and split it half and half with the woman that lost it. I'm just reading those right now, so it just seems, you know, Ron, you're right in the middle of that.
It's a lifestyle.
Yeah. He lives in off on a houseboat near Fort Lauderdale on Slip 61 or something like that. Yeah.
Yeah, one of the things, you know, we were talking earlier, I think Chris was talking about, you know, how he would use a camera sensor to do his line following. Okay, now I've kind of done that with just sticking the camera looking over like this. All right, the big problem is all the reflections on the course give you a lot. Your sensor reading issue is a problem. But the second thing I ran into was actually reading. I was using a MicroPython situation and reading. There's a limited number of pixels that you can read in the time to have a good sampling rate. And so it's not like you can just flash the whole screen and analyze it. You know, you have, because in MicroPython, as far as I can see, you don't even have like a read line. You have to literally do a read pixel, whatever, 640 times across or whatever, 320 across. So you're picking up, you're reading individual pixels all the way across. Now, I don't know if that's, suspect that that's a limitation of MicroPython and not necessarily the camera. So, but what I was thinking of doing to try to get rid of all of the extracting lights was to build a cardboard box. The cardboard, because you want to have something that's extremely light and make it sort of like a trapezoid. I don't know what is a 3D trapezoid?
Well, truncated pyramid like that.
Okay, yeah, truncated
Like
pyramid.
Yeah. Okay.
And put the camera up on the top of it. And now, for me, what I didn't really want to have it sent like Will has done this, and he's centered it over his wheel axis, but his turn radius is actually behind. So I'm not, in my mind, I think that's not really behind. He's not really. I don't know, but I'm just saying I would want it in front of the wheels. Okay.
Yeah,
But now it becomes a weight issue. And trying to figure out exactly how to balance everything. There was at one time, on the surplus market, there were these wonderful Swiss motors that had a 90-degree turn on them. You might still be able to find them, but they're rare now as opposed to what they used to be. And I bought a bunch of them, and I took them all apart because I just wanted the motors. And now I'm going like, oh, you dummy. If I'd have left them as 90 degrees, they could have been put on a 6-inch robot without any issues. Mm-hmm. Anyway, so that's but what I'm saying is I think I want to have that box, the edge of it at the wheel axis and the rest of it forward to that. And like I say, that makes it really front heavy. So you got to have to either counterweight it in the back. Then now your robot weighs a lot, which means that you're going to have a lot of momentum issues.
There you go.
Yeah, there it is. Yeah, that's the motor. Yeah, and it's got an encoder on it and everything. They're sweet. They're really sweet.
Are those still available?
Pardon me?
Ray, did you get that recently?
No, these were from Tanner's a long time ago.
10 years ago, maybe.
But I mean, they were all over. They were at one time all over the surplus market. So, you Goldmine, some of the other places you could find them. But if you ask, you search directly for that motor type, you might find somebody who's still got a pile of them, but they're not like they used to be. It used to be you could just buy them, and they were cheap too.
No, I like stepper motors. I mean, for this line following stuff, stepper motors have served me well. I guess I can show. Where's my robot? Wait a minute.
And here was the motor that Ray showed, and here's what Doug and his stupidity did. He turned it into this. So, but I mean,
you could put it back together if you kept all the parts.
That's easier said than done.
They are very small.
Some of those things are pressed on and other things glued on, but if you were interested in looking for it, well, actually, I've got some here that are by two different companies.
Yeah, they actually have ball bearings in a 3mm shaft. I don't know if you can see that little silver disc, but those are ball bearings on it.
Yeah.
They
were gorgeous. I mean, I'm sure that these cost a fortune when to manufacture because, like I say, they're Swiss motors, and but now they were like $4.
Hey Ron, do you have any photos of your robot online?
Well, there probably is in competition, DPRG, but I don't have any photos online.
Okay.
But yeah, it's I'm just using, I forget what they are. They what NEMA value those are. I guess I could look that up. They're like, what are they, 13?
17s,
They're
I
not
think.
11s, are they?
I thought they were 17s, aren't they?
I don't think they're that big. They're smaller than what you'd find on a 3D printer,
Okay.
typical 3D printer, like a MakerBot at least. But they're, I use the Pololu drivers, the whatever the stepper drivers, and I happen to be using an embed. I kind of wish I was PC, but that's what I wired on this. I might build a PC board one of these days if I get, sufficiently bored with what I'm doing and sick of looking at this. But anyway, I use a Pi in a camera, and that's what I've used on this robot for some time. It does have sort of some legacy sensors that I haven't been using, which are look down table edge sensors and sharp IR sensors that originally, without a video camera, I used for can detection, kind of a drive-by can detector on the side, and then I could rotate 90 degrees, that sort of thing. And there's a gripper for this robot, but I have it detached for the line following. So anyway, I'm just using some RGB LEDs that I'm talking to via SPI from the Pi. And this is the thing I need to, you can see it's coated in dust fairly well. And this is the thing I need to get back up and running, which is, it's up and running. I just have to relearn how to use it to do the line modeling.
Yeah, Murray, some runs of Ron's model are either in the 2018 or 2019 competition.
Or maybe earlier.
Yeah.
Okay, cool.
Oh, there's
Thank
probably some earlier, but I think there's some in 18 and 19.
Yeah, maybe 17. No, I don't know. Okay, you guess it.
Would you consider those steppers pretty grunty? Like they're not underpowered for that robot?
Well, just depends again on how fast of an acceleration rate you demand. So, I mean, I definitely ramp my velocity, and I use kind of the same idea that's used with LFS. A linear ramp or a constant acceleration rate is applied to my expected step count. So, I start off, and you can accelerate fairly quickly, and also it a little bit probably depends on if you're micro stepping. And I think just because I don't like the choppy, jumpy nature of a full step, I probably go with something like an 8th step typically. And I'm sure that sometimes there's a little bit of error in there, but generally speaking, I think I remember doing some can collection contest where I would, go outside the goal and line the cans up. And I could go and I could do the entire contest without any wall calibration. I would have an initial position and go and collect the cans. And so it's fairly accurate. I think one of the things that helped me is I think typically I would do a fairly simple motion profile, or not motion profile, but I would do typically like drive straight or stop and then turn and then drive straight. But I wouldn't do a lot of variable step left and right wheel type thing. I think that I found I had more error accumulating, or errors tended to accumulate faster driving in straight lines and making deliberate turns, that sort of thing, from a stop. So anyway, but I guess we'll see more of that. Hopefully, my goal right now is to get that back up and then to prove up a method of going from an LFS controller, take my LFS controller as is, and then, whatever I might have to deal with things like a slower video capture rate. But ideally, what I'd like is be able to drop a controller directly into the robot from LFS. So that's the goal with whatever image correction. I tend to not use look down camera. I tend to use a look like at a 45-degree angle. But I'm thinking maybe I'll do the transforms, wherein I'll take the camera image and transform it into what LFS would see, so that I can go back and forth between the two. Right now, I don't really sweat it. I just use my camera looking at some odd angle, and I use the type of sensors you saw in LFS, like arcs and lines. And anyway, what am I saying? So there, I wasn't too worried about distortion from the camera, but I'm thinking, well, it might be cute to take video camera images and do a a calibration process or a transform so that it, so I could take that video camera and make it look just like you'd see with your look down camera, that sort of thing. Oh, hello?
Ron, just for your information, I went ahead, when I first started doing my advanced model with, like, I modeled my actual little, the little robot that I made that does line following. We use it for demos all the time. Anyway, when I actually put the sensor spacing in the same location as my real robot, and I got pretty close to what that real robot can run. And that's why I know maybe it needs to be rebuilt, because I could get squeezed some more out of it. So I just thought you might like to know that feedback, that
that you used it.
It seemed to be pretty close, and also I was able to improve it, not my real robot because I haven't rebuilt the base, but in the simulation, I was able to do better than the real robot. So suggesting that if I were to rebuild it, I could make it better too. You know what I mean?
That's how we do it. That's how we do
cool.
Yeah.
Good. Let's see, Ron, were there other things you wanted to show tonight?
I don't have much. I could show, let's see, I could just show I've been goofing with Blender. I finally created a low poly, let's see. Okay, let's see, I'll put that there. Yeah, so I finally created a low polygon version of the DPRG logo robot. He's not super accurate, but the cool thing about him is he renders a lot faster. So I figure if I take LFS into 3D, he'll be very active in that 3D world. But anyway, I've been messing with. I dug out my VR headset, and pretty cool. I created him, and he's about 8 feet tall, and so anyway, Pam liked it. When I brought her in and let her put on the headset, and wow, there's this 8 foot tall robot, sitting in the middle of the office. But anyway, so I've been messing with that. But my skills, it's funny, one of my passions is 3D graphics, and I'm like a 10-year-old kid or younger in doing some of this stuff. But I'm hoping to get a little better with animation, and also some of the the rigging, the skeletal animation. And another interest of mine is I know Will's got like some of his robots, like the cow robot, and I'm interested in taking. Years ago, he gave me the joint positions and all that, and I think an Arduino sketch. And I'd like to go ahead and and animate the robot, but use his controller code and that sort of thing. But one thing I'm lacking right now is years ago with Delphi, I had access to a dynamics engine called ODE, and that was very nice. But I'm kind of hesitant to go back to Delphi. I'm spoiled on Java now, and I love Delphi for its control design. Its GUI design tools are just great. And the same with Lazarus, which is a free version of it's a Delphi-like open Object Pascal that runs anyway with a nice user interface modeled after Delphi. But I don't kind of want to go back there, so it leaves me looking for Java bindings for ODE or another engine, or I'll make the choice of going to something like a game engine like Unreal or Unity. I played with Unity a few years ago, but boy, a lot of these things are pretty complex, and I really like processing for a lot of its simplicity. And kind of what I'm thinking is I'd like to do, like Jean mentioned, I'd like to do simple sketches to help with simple ideas, so you can get a hold of some of the simpler concepts by looking at a 50-line program. Already LFS is a little bit complicated, but at least most of what you do there is, your controller code with just a little access to sensors and so forth. So anyway, that's my story.
Ron, so what's wrong with the off-the-shelf robot simulators, Ron?
It's too fun to author my own stuff. So yeah, I wish I could show you this thing I did back in 2006. It's sitting on my, let's see, I'll get rid of my presentation. Wait a minute.
Hey, Ron, I have a question about your Robbie robot. How cheap could you go to make him appear virtually to, say, at a demo? Let's say we're doing a demo at Moon Day or something like that. If we could have these kids like put on a pair of goggles and all of a sudden an 8-foot robot appeared in front of them, they would just go nuts. And I'm just curious, how cheap? I mean, could you do that with an old like Android phone and one of these virtual reality?
Oh yeah.
Oculus, $300 now.
Yeah. Well, for look around VR, of course, the cool thing about Vive and I suppose some of the Oculus, anything that uses position sensing, that's where it gets really cool. I mean, look around is okay, but when you move your head or when you walk around in a room, that's when it's awesome.
Yeah.
And it'd be interesting to find a way to help create that sort of an idea like that without an expensive VR headset. So
I'd be more worried about is saying, if we took it at a demo, if somebody would break it. You know how those demos are.
Oh yeah.
By the end of the day, almost nothing works anymore because something's been broken or it's wore out.
Well, the cell phone thing. Come to think of it, like something like this with cell phone VR is probably reasonably doable. Originally, this robot, I used my SolidWorks files that I used to make the little 3D model. And of course, everything in that is fully specified as far as volume parts to be 3D printed. Whereas, so now I've taken him down to just much simpler geometry. I mean, all just, thin shell, no, nothing has thickness and that sort of thing. So this would probably render on a cell phone. So you could probably do the look around VR, with a cell phone with a accelerometer, preferably a gyro or whatever, so it can do good orientation. That might work fairly well. I'm not sure if any of them do. Any of the cell phone VR stuff, do they handle any linear acceleration or approximation of motion?
I have no idea.
You're talking about the glass, the Google?
No, I'm talking about
paper.
cost, what's available without
I'm pretty sure they've got the 9-axis IMU in there. So it's just a matter of what you do with it. It's available, right? Because it has to be, because you can get the metal box for the carpenter and it knows the orientation with respect to gravity. So it can measure linear acceleration as well as rotation.
Yeah, I wonder if like the iPhone, do they do any, like they could do optical flow so that if you move that thing around, they could probably, and in fact, there might even be some simple solutions to doing that with a conventional cell phone. If you're producing a fairly simple 3D image, and let's say you're grabbing a low-res camera image, at least have, we'll say, some ability to do just basic motion in front of in front of some easily decodable surface, preferably. But that sort of thing should be available. That's because
the latest one, I think the 12s have. I mean, they have. I wouldn't say it's the same level as a Kinect, but I've understood that this isn't a 12, but the newest iPhone has the depth sensing camera on the backside.
Oh, okay. There you go.
Oh yeah.
Okay.
Yeah, there's
you might see apps, I guess, that are then like at least maybe not room scale, real VR type stuff like you'd get with. I don't know what Oculus has. With the HTC Vive, whatever, they have sweeping line lasers. Two towers. I guess everybody's seen that, right? Where you've got the IR towers that sweep basically invisible line. In fact, each tower sweeps a horizontal line and then a vertical line, and then whatever you have device will have. Probably this has probably a half a dozen sensors on it. So wherever it is, it sees those sweeps. Okay, people know about that.
You
A few
brought
years
that,
ago,
the makerspace, and Carl, I think you tried it, didn't you?
I had a good time with it. When you demoed it at the makerspace, not long ago.
Yeah, it's cool.
Yeah, I've got a Samsung head-mounted display up here, and they don't use that. They use sensors around you and some motion things to track all that stuff. They don't use the. I don't know if it's accurate. I don't know if it's as accurate, but I can't tell any difference.
Okay. Yeah, the nice thing about the Vive is it not only has, so every device has an IMU, at least 6-axis IMU in it, but it's also, which is great because if there's any temporary occasion, of the sensors, I think it's smart enough, it knows how to approximate for data loss. Sometimes the thing does goof up, but boy, it's pretty good. And, at 90 frames a second, provided you're not bogging it down with, trying to have it your GPU.
I'll tell you, there's a place in Stonebriar. Went there just about a year ago. My brother's birthday. He wanted to go, and it's a VR experience. It's like, I don't know, $30 a person or something. But it's a half-hour, 45-minute deal, and they get the newest Oculus stuff where you got a backpack on you with the computer and the whole thing.
Oh yeah.
And you get to pick your adventure, and they have you do all kinds of stuff. In fact, it was real enough where when they told us to put it on and go, that we had to walk onto this platform that was going to take us to our virtual world. And my sister, as she was walking through the little bit of the door that was there, because they had the real world bars and stuff were there if you wanted to.
Oh, cool.
Okay, you could hold them. And so as she was going over, it looked like an elevator with a little bit of a gap in it, like most elevators had. She was like holding on and doing one of these things. And it was way funny. And during the whole time of it, they had all these things around you. Like we went to like the Zootopia, where we had this big dinosaur that sneezed on us. And when they sneezed on us, they had a little jet of air and some water spritzing going at us at the same time. They had other things that they would drop down and you could pick them up. And because they're in VR, they look like this weird ass thing, but no, it's just a softball, and some other things with flashlights and lightsaber sorts of things that you could pick up and move them around. It was a lot of fun. I mean, I thought it was a little on the high dollar side, but I thought it was well worth it if you've not done any of this before. And Of course, and my mom went with us, and she's in a wheelchair, so they had her a wheelchair capable one of these things to put on, and she was scared crapless the entire time. Just close your eyes, Mama. Just close your eyes. You'll be all right.
You've heard of smelly vision? That was snotty vision.
Yeah, that was snotty vision. But it was really cool. I'd like to go. I think I'd like to go back there again. It just soon after that, all the junk started happening, and so I'm like, I'm not putting all this stuff on my face. I just, even though they say they're wiping it down and doing all those things, I'd just rather not. I'd rather not take that chance. Yeah.
Hey, Ron.
Yeah.
I wanted to ask you a question. But little preamble to it. The first time I went to the UK, we took a bus tour, and when we crossed into Scotland, they had kind of a stop, and there was a bagpiper who smelled like he had drunk a fifth of whiskey. He was like, and the ladies were kind of teasing him because he had a kilt on. And they were posing for pictures where they were trying to look up his kilt. So I wanted to ask you, did Pam investigate what was under the front flap of the robot there?
No, she did not. But she did stick her head in the moon. I had a moon with a satellite orbiting it. Anyway, and you could stick your head inside the moon and you'd see the inside, which was curved the other direction. But one thing I can tell you is one of the demos that I think they call it the lab. Anyway, there's a miniature solar system, and I'll tell you, it's so weird as you walk up to the sun, and this thing is kind of flaming. the visual cues, you swear you feel heat. And it's, you know,
really?
it's the weirdest thing that it's really interesting. And I don't want to say every time, you know, after a while, but when I first experienced it, as I approached, I believed I felt heat, you know, and I thought, you know, I knew that wasn't the case, but it was just that cue, you know, it's so believable. Anytime you've been up near something, it's going to feel hot. And so I felt the heat. So it's very interesting. Another experience is playing Rick and Morty. I remember being in the bathroom. There's a bathroom, so there's a toilet and a sink very close by, or a counter. And I remember something fell between the toilet and the sink, or the counter. And I remember kind of reaching down real carefully, you know. Of course, it's virtual reality. I wouldn't have to do that. But I found myself, you know, in that situation. I was grabbing something off the floor that was between the toilet and this cabinet. Here I am, you know, down here, carefully reaching, you know.
I have no doubt that the people not in VR, you know, they're making sure we don't tumble off ourselves and kill ourselves in the thing with all the masks and stuff on, are laughing their ass off at us. I got no doubt about that.
Yeah. I think you could knock someone over very easy. I mean, you just make it like the, you know, what you're seeing moves in the opposite direction, and you try to compensate all over.
Yeah.
So,
one of the first times I did that, I was in Vegas, and I did it with a whole group of folks. And what they had to do, they had to put you in like a climbing harness, and they had you basically bungee to the ceiling, so you couldn't do too much harm to you. And they gave you a run through, and one of the basic run through is you put on the goggle, you have your controllers, and they say, okay, we're going to do this. Move your arms. You see it move, so you'll see it in VR, your arms and stuff moving. Okay, look around. Okay, now we're going to drop the floor out from underneath you, because that's what's going to happen, and you're going to be flying around like the simulation was like Superman, flying around Superman. So we're going to drop it out. Just be ready for it, but know that you're still on the ground. And I swear to you, they dropped that floor out, and my stomach went through the roof, just like you would if you just drop a floor. Yeah, you got that sensation.
Yeah, we rely on a lot of visual cues for that stuff, and if you play around with those, it could probably make you sick.
Oh yeah, let me tell you, the blender. Most of the stuff I've played with, you know, I create something and then I have, you know, the cameras fixed to you. But the weird thing in Blender is when you do some of the operations that might affect the scene zoom or panning it, now you are messing with altering the scene with respect to you. And boy, let me tell you, you can get sick really quick. I mean, I took my model, or I just rotated it, and I, you know, wow. So I could see where one is slow frame rate or lag, but they're dynamically changing things where you're not feeling the motion. But, that's quite disturbing.
Hey guys, I'm going to drop out of here. I don't know what's going on with my system. I don't even know if you can hear me.
Oh, we can hear you. Yeah,
but
I was going to ask if there's anything to share, but
I'm missing about a quarter of the conversation.
Oh no.
I'm talking choppy. I leave out about a fourth of my words. Really nice.
I appreciate
it.
That's an awesome thing. It's just that my computer says I'm reconnecting all the time.
What's the real reason you're leaving?
Not at all. It's just
you got one of those Google glasses.
I can't hear all this wonderful kibitzing going on and things and all this kind of stuff, and so I feel at a loss. So I would, you know, I'll catch you guys next week. I will.
Okay, great. Well, we could hear you, and that was nice. Thanks.
Send warm thoughts to your connection, Harold. Take care.
Okay, take care.
Bye.
All right. We finally got rid of him. Okay, who's next?
Hey, can I ask you guys a quick question? I find this battery too bulky. It's a 12-volt battery. Do you have some recommendation? Maybe under $50, something like that.
Like lead acid? What kind of battery is it?
It looks like lead acid.
Oh yeah, lead acid.
Lead acid battery.
Very heavy.
So I can't fit it on my on my vehicle.
Well, yeah.
With ease.
Let's see. 12 volts. The big deal is I personally like having less capacity and, you know, the ability to change out a battery. But I mean, with a 12-volt battery, there's just depending how big your motor. What are you running like those? You're running those motors like the club uses for the club robot? Right?
It's the one Carl has. It's not high power. I don't think it's high power. But
check out what Murray's got.
Is it like these?
Murray's muted.
Like Murray, those? Like the Pololu? Are different.
Yeah,
they're
of course these are really small, right? Those are what the club uses, I think.
Yeah.
Now
okay.
I've been using these big 18-volt batteries that have a clip on the top like that, and then I've hacked the clip, and there's a 5-volt USB, but I've hacked it and just put a power connector. Now this is Makita, but most companies make something like this. This is Makita's 12-volt version. It's quite a bit smaller. This is a 1.5 amp hour. They also have a 2 amp hour and a 4 amp hour. And they have on the 4 amp hour, they even have a little button on it that gives you a gauge of how much is left. This is not very heavy, and this is actually what I'm going to use on my small robot. And they're not, but they're very safe, and they're not very heavy. I don't know what that weighs, but it's pretty light.
Oh, okay. Amp hour is the capacity. I see.
Yeah.
I do have these power tool battery, like
what about
the one for the drill or something
that you had, the protected 18650s. He might like those.
Oh yeah,
that's what you're talking about is power tool batteries.
I like transmitter batteries, but not that that's anything special.
Yeah,
they're sort of limited.
Oh, okay.
5 amp hours. This is only 2.2.
So I think the one Carl has is 2.2 too, isn't it, Carl?
No, these are 3.5 amp hours, 18650s, and they're protected.
Yeah, that's
wow.
And they're protected. So they're pretty
it's
nice.
not just a normal battery clip. Okay, I thought.
Well, I made my own pack. I got the connectors from DigiKey and Earthboard.
How much does it cost?
These were, I want to say they were like $10-12 a piece.
Okay.
Are those 18650s?
It's 12 volt?
I mean, that's
those are 3.6 or whatever.
They're single cell lithium, but I got 3 of these now. It's 36 watt hours, right? So
is it 12 volt?
That's expensive though. That's $40 plus, right? 40, 50 bucks.
I think it's
20. This was $35. That's right. Yeah.
Carl, that's like one battery is 12 volt.
No.
Yeah.
3.7 volts.
No. Each one is about 3.5, 4 volts, right? 3.6.
Oh, okay.
They're all in series.
Fully charged is 4.2 volts. So all told, times 3, that's 14.6. And then when it runs down, it's lower.
1.1.
But Kareem put a nice link in there from Vex that you could look at. Nickel metal hydrates are a little safer than lithium. The only thing you're going to need, John, is that you get all 4. When you start doing some of the crazy maneuvers with all 4 of those mecanum wheels at the same time, going different directions, you might see spikes of 5 and 6 amps. At least I have. So you want to have a capacity that can do a high peak surge. Even if they're only 1.5 amp hours, you want to have I don't know what that is, 5 or 10 C discharge.
Carl, that's precisely why I decided I wanted to use power tool batteries. Is I just figured they could do it.
Yeah, and that's what's nice about those Makitas is that and ones like them is that they've got the protection circuits built in and the charging system. All you need is a way to mount it.
Well, that's hard.
Let me show you guys my power tool battery.
The mounting isn't so bad because they make a clip for this one like they do for the bigger ones, and that clip is just a hollow plastic thing. You could put screws into it, and that's kind of what I'm planning to do. And then I just turn my robot upside down and put the thing onto the clip.
That's even better than duct tape or Velcro, huh?
What is a good way of mounting this? Like this is
That's like actually Harold has like that.
That's the Ryobi, right?
Yeah, Harold made a 3D printed plastic thing to hold his.
Yeah.
Yeah, it's light. Okay. But it's a good idea if I can use this. It's a good idea, right?
Yeah,
absolutely.
Okay.
Very
It's
safe.
a lithium pack, isn't it?
It's lithium. Yeah, lithium.
Yeah, so it'll have a good energy density, so energy to power to weight ratio, and it'll have a good high surge power capacity.
Mm-hmm. Okay. Yeah. I'll
Just gotta
try
mount
to
it.
use it. Cool. Thanks.
Yeah.
It's definitely lighter. Yeah. Thanks.
So like Carol, he'll probably get you the 3D files if you wanted for a mounting bracket.
I think, yeah, I'll probably, I don't know. I don't have a 3D printer, but I'll probably use something to duct tape it or something.
There you go.
Yeah. Yeah. All right. I'll try it out. Thanks.
Turns out I just found in New Zealand the prices are kind of crazy, but I just found this battery in the 2 amp hour. This is a 1.5, but there's a 2 amp hour version of it, and it's on Amazon right now for $25. So you'd have to get the charger, but this is the 1.5. There's a 2, and there's also a 4 amp hour, and the 4 amp hour is about $50. But and I can only vouch for Makita, but I'm sure most of the power tool companies will have that kind of thing. And this is
the
like I
amp
said,
hour
25
is the capacity. Does this like in terms of current capacity, does it matter if it's 1 or 2 or 4 amp hour?
Well, amp hour is basically 12 volts is how much, you've got to match the voltage, but the 2 amp hour is basically how long your robot will run.
Right. Yeah. But if I say I'm not concerned about the length, I'm more concerned about the instantaneous current, like the
Okay. That's
the
the C
stability.
Sort of what Carl was talking
C
about is that
rate.
these are designed for power tools, and and a power tool has a big motor in it. So these are designed to handle the shock of a big motor, like a drill being stopped. So I don't, the smaller batteries that are just general purpose lithium ion, you'd have to either build your own protection circuit or take very good care of them. Whereas with these, they're safe because even if your drill stops, the battery's not going to explode on you. And it's something to think about.
Yeah.
50C. Here's what Ray's got.
See.
5.2 amp hours, 50 times charge rate. So
Yeah, see, 50C is how much instantaneous current. So this is 5.2 amps.
5 amps times
50.
Yeah.
Times 50.
So that can pump out 250 amps instantaneous.
That's
All
why if you short them out, they can kind of like,
it's a bad,
a lot of current.
Yeah.
Oh yeah.
Yeah. I mean, if power tool battery is the good choice, I'll try that. Yeah. Cool. Thanks.
If you open them up, what you'll find is essentially a stack of the batteries that Carl showed you. And I'm not sure what their typical 18650 cell forms have unless they're like the one that Carl showed you. If you just buy like a 2.2 milliamp hour 18650, they've probably got a 2C rating. Okay, so that means, or maybe even 1C, because they're about 2 to 4 amps before that's absolute. The one Carl's got will do like, I think about 10 or 12. So, I mean, but that's plenty for a small robot.
Yeah. Yeah, the motors are not high power. I can hear the sound. It's pretty pretty
I'm just telling you, John, with 4 of those motors, you're going to need 5 or 6 peak amp capability, because I've measured that. I have a volt amp meter on the robot that I showed the video of Saturday, and you'll see if you start slewing around edge to edge, you'll see 5 or 6 amps peak from the battery to drive all 4 motors. And like Kareem was saying in the chat here with Mechanums, I mean, right? They're all, the forces are all opposing each other, right? So they're all fighting each other all the time. That's how they work, unless you're going diagonal or something. So,
yeah.
Yeah, these don't rate the C. They don't have it labeled.
I looked up there. They have a spec sheet on it, Carl. I want to say it's either 2 to 4. Those are high, what they call high current ones.
They're high discharge.
Yeah, they're high discharge, and I think they're about 4C.
Sure. Well, even at 4C, that's still 15 amps.
Yeah.
It's amazing how
So-
much current they can provide.
But that's not, the high discharge is not the normal cell. If you get,
Right.
just go down and buy a cell, it's probably at the max, 2C and probably closer to 1C.
Mhm. Now, with this kind of battery, this 6-7 amps is okay, right? Okay.
Yeah.
It should be able to pull it.
Yeah.
But you
I
can
think-
you can open them, well, if you buy a new one, you don't want to open it up. But if you open it up, you can see what type of cells. They're usually 18650s.
Or you can just hook it up, and if your processor resets when you slam the motors, then it doesn't have enough oomph.
Yeah.
I'll give my processor like a dedicated. Probably I have my laptop on there, so something like it's gonna be a separate house.
Power.
Yeah.
But you definitely need, like Cole said, be able to pull 6 with 4 motors for sure.
Yeah.
Uh,
So the one Corinne has, is this? I have to make a custom mount to use that, or
no,
it's
that's Harold, isn't it?
Duct tape.
Oh,
Harold.
Harold.
One that you put in a 10 cell, 12 volt, 3 amp hour battery, low profile, 20 amp replaceable fuse. It's got an XT30 connector. It's got a 10C maximum discharge rate, so 30 amp discharge rate. So
I
with the
see.
inline fuse, it holds it to 20 amps, $50. I mean, that's pretty nice. So
It's not super cheap, but it's very safe. You're not gonna have to worry about it blowing up or anything like that. So that's why they restrict high school teams to using non-lithium technologies.
oh yeah, it's nickel metal hydride, right? So you, but still, I mean, so you charge these without a balancing charger, Kareem?
I do. Yeah, there's no balancing at all. They're pre-matched, and they are pretty reliable. Don't overcharge them, but you can deplete them pretty deeply also. So lipos, if you deplete them too much, you're basically killing them.
Yeah. No, nickel metal hydrides are what nickel NiCads always wanted to be, but never could.
That's right. Yeah. The main downside is that they're definitely heavier than lithium batteries of the same volume.
Looks like it's easier to mount.
It's I mean, you just got to figure out a rectangular place to put it. Basically, the teams always design the various of their own mounts, but you just basically got to create a slot for it to sit in. And that's, and then you just, and if you have multiple of them, they swap out really fast. And we just use standard XT30 connectors, which are used a lot in hobby and drone.
I understand. Okay. Yeah,
Actually,
I'm thinking making my own connection takes a while. Probably takes a while, but yeah, that looks good.
John, what I did on my robot is I just have, since my battery is actually weighs almost as much as my robot, which is probably not unusual. I just made a space right in the middle of the robot with 2 little pieces of aluminum angle that fit the bottom of the battery, and then you can buy really, really thin bungee cord, and I just pull bungee cord over the top and just tie it down. It's really easy. You could use Velcro too, I guess, but I'm
It's
just
like you're sitting it in the slot, tie it down, right?
Let me see if I can. There. Okay. I'll just pick up my robot. So I'm not sure you can see this. So basically, that middle space on my robot is where the battery fits, and I just slip it right in there like that. And then if I'm going to take it outside and run it around, I'll just put a bungee cord over the top and tie it down. So it just fits right into the middle of the robot. And there's a little bit of rubber foam there to keep just for shock value, I guess.
How does the connection go? Like the electrical connection?
Well, I don't have that style of battery. My battery doesn't have that one has a post, which is the same style as Harold does. Mine has this kind of a clip, and it just connects on that. And what I did is I undid the 2 screws, opened this thing up, and I just hacked it, and I've just put a power connector up here. So I've made a power connector because what they have on them is these little slots that have, you could put a blade of metal in there, but I didn't want to muck around with it. It just seemed, you've got this quite powerful battery. You don't want to short it out. So I just hacked this part. And like I said, these small ones also have a clip. It's an ADP-08, and this is an ADP-05. And what these are meant for is that once you put this on there, you get a slot there for your USB connection. So you could get a 5-volt power supply off of them, but it's not very reliable. I just used it as the clip. I really just wanted one of these things just to make that connection easy.
I see.
And on my smaller robot, what I'm going to do is use that as the connection. So I'll actually screw that to the bottom of the robot, and then then I'll just push the battery onto it. And then when you want to take it off, you just push the button on the battery and pull it off again. So this becomes my mount, actually.
Why did you say the 5-volt power supply wasn't reliable?
Because I used it. It's good for charging a cell phone, but I wouldn't use it for your robot. Really, it's not a very highly regulated 5-volt.
Okay.
The board is all discrete components. It's very old school. If you put that 5 volts into something else, you could maybe put it through a 3.3 volt regulator and use the proper regulator. But it's not really, it's a power tool thing for guys out in the field. It's not really meant for electronics. It's designed to charge your cell phone, I think, is really what it's for.
I have one of this. It's like a car starter, Have you guys seen this? Like, I got it from Costco. When I bought it, I thought maybe I can use it for robot. But
what outputs do you have?
So there's like 12 volt. Basically, if I plug this in, if I plug this into this slot, and it's 12 volt, but
it's kind of bigger than your robot, though.
The connectors are awesome, though. They would be great to have your robot with those connectors. Just crank it up and give it
something off, right? But this is hard to connect.
What I did on Saturday is I actually used one of those to power Robbie, the Raspberry Pi, with the USB connector, just as a temporary solution to get the 2 batteries, because I had the 2 things and I didn't want to get the 5 volts lined up in time to be able to shoot the video. So I used that. I was a little surprised that it depleted faster than I expected it to, because it holds such a tremendous charge to start cars.
Yeah.
I thought it would last longer, but it didn't seem like it was going to. I'm going to do a test to see how it compares to a couple of the 18650s. I'll keep you posted.
Yeah. Kareem, on that battery you showed, since it's nickel metal hydride, is it one of the ones that has the where once you charge it up, it stays charged for a long period of time? My biggest problem with those was that every time I wanted to do something, that started off with me having to charge the battery to get it fresh. Are these, do they hold a charge? They did some new technology, I know. And
nickel metal hydrides hold their charge, I'm going to say, for like weeks at a time.
So for a week, yeah.
Start diminishing. They won't have as much shelf life as, say, a LiPo.
Oh, no.
But you don't want to store a LiPo fully charged anyhow.
No, right.
It's not like an alkaline that'll last years and years, but it's also not as dangerous as a lead acid, which will deplete and then, and it might deplete below its survival level pretty rapidly.
Yeah.
So you can go between charging for months at a time and they'll be safe.
Okay, that's cool.
You can find these charts if you look around. Like nickel metal hydride will self-discharge at 50% after 1 year.
Yeah, that. They used to be even worse than that a long time ago.
Alkaline is 95%
Yeah,
a year.
10 years.
Lithium, yeah. So
Yeah,
I
nickel
forget.
cadmiums used to have the memory effect.
Yeah.
Yeah, and then the nickel metal hydrides are supposed to have the memory that NiCads did, but I've still had issues with nickel metal hydride wanting to be cycled, or they develop. I mean, it can't be memory issues, I guess, but I still have had issues with them.
Well,
They do have some memory, but nowhere near as bad as NiCads.
Yeah.
Yeah, I guess, I mean, that looks like a good battery that Kareem put up there. But, I kind of shy away from nickel metal hydride because, like I say, I've always found every time I wanted to use it, it was always discharged. So I always ended up having to recharge it. But that is a good looking battery.
I think that one of the things that is in a weird way good about lithium batteries chemistries is that you know now that you have to treat them really well.
Yes.
Whereas with the nickel metal hydrides, we can lose a battery every once in a while because students get really sloppy and they will torture those things, right? But that's something you cannot do with lithium because then it becomes dangerous. So it's almost like they're abusable enough that you're tempted to over-abuse them.
Hey, can I go?
Yeah, please, Ray, pick you up.
Carl. Oh, you're still presenting, Carl?
Oh, I am? I didn't
Yeah,
mean to.
we were wondering what you were doing.
All right. That was the project I had to do Sunday after not doing home projects for too long for Robot Club things.
Okay. Okay, can you see it?
Yeah.
Presentation. Okay. Anyway, I had a bunch of CNC systems. Most of them I'd have to take my laptop over or have a, I had an old desktop that I have sitting over in my metal building, and I could load things to it on a, a USB memory stick. And I wanted to get them all so I didn't have to carry a laptop over. So I have a 3D printer that I can bring actually an SD card to print. I have one of those 3018 small CNC mills. These other three things, I have an XY table that's mounted on a drill press. I have the pieces for the plasma table and the pieces for the CNC table, but those aren't built yet. But I wanted kind of the same interface to all of them. And so most of them, kind of the simplest approach is to have one of these CNC shields on top of an Uno, and you can either use the smaller drivers for like NEMA 17s, or you can go to like higher power drivers. Like one of these is based on the TB6600, good for 4 amps and DC voltage, input voltage. You can go from 9 to 42. This one's rated a little bit higher. It's 5 amps. These, I think I've found them for like, I think $12, and the higher ones for 13. It's just an amp more. So on the 3D printers, and this is kind of an older approach. A lot of this has been integrated into one board. They're not monochrome displays like this one is. They're color touchscreen displays, and they have really nice graphics on them, but they're many, many more times expensive than the older Ramps boards and the monochrome displays. But That's fine for me. I can pretty much do everything that I need to do. I can set, like the XYs and Z0 points. I can download G code files to them. I can insert, into this unit. It's got a slot for an SD card, so that's very convenient to just bring it over there and do it that way. You can buy, CNC kits that include, the simple board or a ramps board and, all these drivers if you want. And larger stepper motors, those are higher powered NEMA 23s. The other thing that you can do, Protoneer makes a board for a Raspberry Pi. It's similar to that. It's got the same processor, the 328P on it, and sockets for 4 drivers. And you don't have to use these though if you have more powerful motors. You can use the larger drivers with it if you want. And I have one of those, and that's kind of nice. And the other thing that you can do, instead of using a universal G code standard, you can download something like BCNC, which it's got more things integrated into it. It has a visualizer, so you can actually see the paths and where your cutting bit is. You can move around the the gantry or the bit and place it where you want to place it. You can single step through. You can control the feed rate, increase or decrease it. And it's all self-contained, and so you can just plug the USB stick to those to the USB slots on the Raspberry Pi. So it's really kind of handy to use. It it has higher integration than like the approach with this, because you don't get a visualizer with this. So anyway, that's what I've been working on, trying to get all of these with the latest firmware versions on them up and running. And you have to do some experiments with the setups. I have some larger slow syn steppers that are like 300 ounce, for holding torque. They're fairly large, but here's one of them here. So as far as the size of the stepper that you can drive with those things, it's a pretty good size stepper. And
Wow.
I don't know.
Pretty healthy, yeah.
We can't see it, right? Can you? There you go. There you go.
Upside down.
4.6 amps.
Yeah.
Okay.
Oh, it's upside down. Oops. It is. Anyway, yes. Stepping motor. Got them on eBay a long time ago, and the first thing I made was like an automated wooden bowl carver. So I had a router head mounted to the XY table, and you could put in whatever profile you wanted to repeatedly carve out the bowl. And for that, what I wanted to model, I think they're called catenaries. It's like if you hang a chain or suspend a chain from 2 points, it follows I think a hyperbolic cosine, and it has an appealing shape to us. And it's because it's a shape that occurs naturally, or in nature. If you ever suspend something that's loose, even rope, wire, string, like that, it will form that shape. So anyway, I just wanted to get it so I didn't have to bring my laptop over. I could bring either, a full-size SD card or, a USB memory stick. And, that would be so much easier than dragging my laptop back and forth or some other computer. But so far it's worked pretty good. I'd like to I have a pile of pieces here in my office that metal pieces that I need to stick together and just bring over there and set up and get it working. I think probably the one that's going to be the most difficult is the plasma torch, because plasma torches are very noisy, and I'm not certain if it's going to, make me skip forward or backwards or lose steps or things like that. So
I think the main thing on the plasma torch one is that it's got to be one of those ones that's self-starting, where
yeah, I've had that issue with mine. I didn't have to bring the tip down to start it. And it's just it's one of the Northern Tool ones. But you could do that with a stepper and just have a 2-axis and have the stepper move the tip up and down on on a handle, or on the torch head.
Yeah. Right. Something just for completeness, not, just because you were investigating different boards and stuff.
Yeah.
One that you probably ought to add on there that kind of, it's a Gerbil board, but it's called a Super Gerbil. It's by Awesome Tech out of Australia.
Oh, okay.
I'll put a link, but
okay.
But I used one of their boards in my K40 and with Lightburn, and it's as good as the one we used to have a long time ago that was made in the United States. I can't think of the name of it. I mean, it is just great. It's a great setup. Yeah. If anybody had a K40, I'd say I'd definitely go ahead and do that. Okay, I'll put the link in.
Okay. So is it one of the 32-bit ARM board based controller or something?
Yeah, it's I can't remember which processor, but it's one of the STM processors.
Oh, it is. Okay. Yeah.
Yeah, and they essentially have two products. One is what they call a mini Gerbil, which is what I'm using. But when they did their Kickstarter, I also bought one of their Super Gerbils because, well, I wanted to see it happen. And so let's see here.
Yeah,
This is you can look around. It comes in 3-axis, 4-axis, and 5-axis. But the 3-axis is probably about $120 if I remember right.
Right.
And it goes, every axis gets pretty much is more pricey.
Yep.
But
yeah.
I don't know if the drivers could handle 4.6 amps, but you might consider it. And in the case like a plasma torch,
yeah,
Lightburn it's really great software.
Is it Lightburn?
Yeah, Lightburn. Oh no, it's like $30 or $40. It's really inexpensive.
Okay, so awesome tech, huh?
Yeah, Awesome Tech is, like I say, it's out of Australia. He used to make one that was basically a fancy Arduino one, and then he finally stepped up and made it with an ARM chip, and then, like I say, the mini Gerbil is 2D, and that one's like $80 or something, I think. And so, like for a plasma torch, that's pretty all you need.
Yeah. To move around a torch, you could probably do it with NEMA 17s. I mean, there's.
Yeah. I mean, I'm saying is you use his mini Gerbil board plus Lightburn for $100. You'd be golden.
Oh, good. Okay, I'll take a look at that. Yeah, I saw there's like the ramps board is the one that I showed was the
Yeah,
1.6
I wouldn't go there anymore.
now.
I mean, yeah, I wouldn't go there anymore. I'd
Yeah.
go with this guy.
Yeah, yeah. And they were like $6, you know.
Yeah. I mean, I got a slew of them. Because I made a whole bunch of 3D printers that use them.
Yep. Yeah.
Yeah.
Yeah. So I'd like to be able to use the Raspberry Pi on everything, maybe except the little 3018, just because I have one of the old ramps boards, and
Mhm.
I don't know. I don't know if I need
Yeah.
something as nice as the
Yeah. But
Raspberry Pi.
you might also think, what about Optoprint?
Yeah, yeah. I suppose I could do that, but I'd have to run an Ethernet cable or something. Or I don't have Wi-Fi over in the
Oh, okay.
middle building, so yeah.
But wouldn't it be nice if you had Wi-Fi in your metal building?
That would be really nice.
Oh, so maybe that's a project.
Yeah. Well, that's the other thing. My hotspot is my phone.
Oh yeah.
So I'd have to bring, my phone over there, so it doesn't get great reception in the metal building. So, but so that's what I've been working on. Just
Cool.
trying to
Really
utilize
cool.
that stuff and kind of
I
have
really would like to hear what you learn when you do the plasma torch thing. Dave and I have some simple plasma torches. We have some, what do they call them? Hero Cut I 35 eyes. We both have one.
Hero Cut, huh?
Here, I think they're Hero Cuts, but I don't know if they'd be suitable for, CNC type cutting. But for fun, for as much as I use a plasma cutter, which is not that much, it's great.
So how do you?
I would think you could use it for the CNC if you're not doing very thick metal.
Well, every time I look on the web about using a plasma cutter for CNC, they always say there's this feature that you have to have. And I think that's the one where it strikes an arc automatically or something. I'm not sure exactly. And ours doesn't do, I think ours is you push the switch and it's cut, Yeah, so anyway, but I tell you what, I wouldn't mind trying it to see if I could, if it worked, that'd be great.
Yeah.
Because doing it freehand is not cool.
Yeah, and they're mainly simple plates that instead of burning drills, but cutting through thicker sheets and stuff, you can just blast a plasma hole with it.
Yeah. Well, the ones that Dave and I have can do, if you're just trying to make a hole, probably can do 3/8 of an inch, I think.
Oh, at the minimum?
Huh? No. It can go. It can go from. Otherwise, it can go from like this up to about like that.
3/8 thickness, you mean?
Yeah, 3/8 thickness.
Yeah.
Now 3/8 thickness steel is pretty thick. I mean, if you want to cut through 1/2 inch, I don't know how many times you want to do that. You'd have to get the 45 or the 55, which goes up in cost.
Oh, okay. So what is the name of it again? I didn't catch it.
Hero Cut, is that right, Dave?
Yeah.
Yeah.
Would you happen to have a link?
They pop on and off on Amazon. They're not always available.
Or how do you spell it? It sounds like Hero Cut.
Hero Cut. And we recommend getting the 220 version. Let's see. Yeah, see, right now I don't see the 35 popping up. Oh yeah, there it is. 100 right now. It's $149.
And that's the cable or the torch?
That's the whole machine. It'll work right out of the box.
Really?
Yeah. Well, you have to supply air.
Yeah, that's another issue. Yeah, mine is, it's definitely 220. I know that, but I forget what the current rating is. I think it's like 40 amp is what I want to say.
Yeah, ours it takes a 30 amp.
Does it?
30
Okay.
amp 220.
Yeah. How do you spell that, Doug? I can't understand.
Like a hero.
Oh, hero cut. Okay, gotcha.
I'm sorry, that's the Smile Amazon thing. You can look it up on Amazon for a shorter link, but let's see. I always do on Smile, so I don't have Amazon anywhere.
Okay, I'll take a look at that.
Yeah.
Anyway, I got all this junk. I need to get it all together.
Yeah, sounds like they got a lot of cool projects going on.
It's going to be.
Yeah. I've had the motors and the Pro-10 year board for probably 2 years. And 2 years ago I got up and said, yeah, that's neat. And then went off and did a bunch of other stuff.
Yeah, I know how it is. I still got a little router that I've been working on, and I made the mistake of thinking I wanted a 24 by something bed, and in actuality, I probably wanted a 12 by 18 bed, and so all the parts are way too big, and I'm having to figure out how to recover from that.
How to scale it down.
Yeah.
Okay. Well, that's kind of cool. I wish I had known about this plasma table setup before I did all the things that I did. It's certainly easier to just buy it.
Yeah.
So, okay.
Well, that'll be quite the shop when you get it running.
Yeah.
Ray, we're going to want to see.
Think of all the crazy things we could make.
Yeah, I know.
Anyway, that's all I had. I know it's getting late.
Okay, cool. Nice prezo, thanks.
Sure.
All right, so is there anyone else that we have not touched on? All right then. Well, let's pause for this night and carry on again next Tuesday night. Until then, next Wednesday morning, afternoon. Ciao. Have a good week, y'all. Take care.
Take care.
Take care, guys.
Bye.